Okay, we're live. So welcome to, for all you people on the internet, welcome to DC404. Go for it.
Good afternoon, everybody. Thank you for coming out here today. My name is Robert Harris, and I want to talk to you all here. I've got a lot of information to cover about radio frequency or RF hacking. So a little bit about myself. I got interested in radio in the early 90s, picked up a scanner, messed around with some CDs, things like that, and I wanted to learn more information about radio. So I eventually got into ham radio. When I was 15, I got my first ham radio license. I've got a lot of interest in ham radio, building a lot of equipment, emergency operations, remote operations, things like that. There's a lot of different aspects that it covers, and we're going to talk about that here a little bit later on. Professionally, I work for a well-known security research group. I'm a vulnerability analyst. I go through and look at weaknesses in applications, systems, go through, do a full technical analysis, write up on that. It goes out to our intelligence feed, and then we also create countermeasures off of that research work. I like to have fun, I like to joke around a lot. I don't take myself too seriously, so feel free to laugh at stuff as we're going through here. Ham radio is probably one of about 40 different hobbies that I can enumerate that I have, and there's not necessarily ham radio, but radio in general. So this is just, I move around between hobbies an awful lot, and this happens to be one of about 40 of them that I have. So for this presentation, we're going to talk about a wide range of different RF topics. Now, one thing that a lot of people associate with RF is looking at, say, technologies like 802.11 and Bluetooth. That stuff doesn't necessarily interest me a whole heck of a lot, so I really don't cover it. I mentioned it a couple of times, but I really don't cover it. If you're interested in that, there's a whole lot of other excellent sources for getting 802.11 Bluetooth hacking type information on that. So this all focuses on things RF-based other than 802.11 and Bluetooth. I wanted to go through and kind of just present awareness to people, try and generate some type of interest in radio, but also take a look at a lot of the different aspects that can occur when using RF systems. Most of the concepts that we're going to talk about in the second half of the presentation are illegal, so please do not go out and actually do any of these things. I went through creating this presentation, started with an outline to put everything together, and I had to leave out about half of the information that I actually wanted to cover. We've still got 85 slides of information to go through from half that I decided to leave in here. So a few things we're going to go through here very quickly on. Some of the concepts we're going to talk about can literally take several days to appropriately cover. I'm going to try and talk about them in a double-digit number of seconds. So we're going to go real down and dirty with some of these things.
When do we get to the illegal part?
The illegal part's the second half of the presentation. So the concepts that we're going to talk about, we're talking about like the most common use cases on these. There's always going to be exceptions to pretty much everything we're going to talk about in here. I've got some demos we're going to go through and do, and I've actually got some stuff that I'm going to give away. I've presented on RF stuff before with SDR, and I have some people come up to me afterwards and say, well, how do I, like, I'm a student. I don't have a lot of money. How do I get started in this for cheap? We're going to talk a little bit about that, but I went out and I bought a Baofeng radio that I'm going to give away, and I got tools that I'm going to give away, and I've got a ham radio license manual that I'm going to give away as well. So feel free to ask questions. If it's something, though, that is like super specific, I may just ask for you to hold off until the end and we can talk about that kind of one-on-one or something like that. So I want to start off with talking about RF basics. So what are we talking about when we're going through looking at RF signals? What are some common concepts that you really kind of need to be aware of? So this isn't a physics lesson. We're not going to get down too far into the weeds, but these are just some terms and concepts that you're going to see when dealing with RF. So when we're talking about RF, we're dealing with a radio spectrum. And within that spectrum, we're using radio waves for remote communication purposes. Those waves travel at the speed of light. Two terms commonly used with that. We're talking about frequency. It's measured in hertz. Typically will be expressed in either kilohertz or megahertz. Our wavelength is going to be measured in meters and typically will be expressed in either meters or centimeters. It starts with about anything that's just above audio, or actually right in the middle of the audio spectrum technically starts, and goes all the way up to infrared, visible, and ultraviolet light. Sometimes you'll see that expressed as the radio spectrum expresses DC to daylight, and sometimes you will see people refer to certain radios that way. So this radio operates DC to daylight if it has a wide frequency coverage. When we're dealing with radio waves, we do require an antenna for proper reception and transmission, and there is naturally occurring radio activity. So if you've ever been driving down the road, you've had your car radio on AM, and you can hear lightning pops in the background is a good example of that. So the atmosphere does create its own radio energy as well. So looking at frequency versus wavelength, the most important thing to understand with frequency versus wavelength is you have an inverse proportionate relationship between the two. So as your frequency, your wavelength is going to decrease. As your frequency decreases, your wavelength is going to increase. When we talk about the number of cycles that a wave completes going past a given point in any particular second, so if we're talking something as a 10 megahertz signal, it creates 10 million cycles going past one particular point in a second. And our wavelength is, if we were to actually draw out the wave on paper, and we're going to pick two identical sequential points on that wave. Usually you measure from, say, the peak to the peak or the trough to the trough on a particular wave. That's what we're talking about with the wavelength, is what is that distance between those two points on there if you were to actually plot this out somehow. There's a real easy formula to use to convert between the two. If you take 300, which actually you're talking about the speed of light here, 300 million meters per second, dividing that by the frequency in megahertz, so it's going to bring you out to the wavelength. So if we have a signal, this happens to be in the 2-meter ham band, 146.52 megahertz. 300 divided by 146.520 comes out to 2.05 meters, or we just call it 2 meters. If you have a 6 megahertz signal, that's about a 50 megahertz wavelength. Does anybody know what operates at 6 megahertz?
WWV?
No, you're on the right path though. It's Radio Havana, Cuba.
Oh.
It's fun to listen to.
No, well, 10 megahertz is WWV.
WWV is on 10 megahertz. I got a slide for that later here too. So we're talking
5 and 10.
2.5, 5, 10, 15, 20, and they have an experimental transmitter at 25. When we're talking about this RF spectrum here, the important concept to understand is that it's broken up into bands. And these bands are broken up by factors of 10 for the wavelength. So for example, we're looking at, say, the HF band here, high frequency. It runs from 3 megahertz to 30 megahertz. Well, at 3 megahertz, 300 divided by 3 is a 100-meter wavelength. So we start at 100 meters. Going up to 30 megahertz, 300 divided by 30 is 10. It goes up to 10-meter wavelength here. So we go from 100 meters to 10 meters. Stepping it up a notch, VHF, we go from, this is 10 meters up to 1 meter and so on. So as we're going through these bands, they have some different properties, and we'll talk about those here in a little bit. So these different bands are broken up, and I know this is impossible to read here, but I wanted to give you a good idea of just how cluttered sometimes these bands can get. So here we're starting off, this is the medium frequency band, HF band, VHF, UHF, super high frequency here, and you can see that this is carved up into a number of different pieces. Those are also sometimes referred to as bands as well. So the terms can be kind of used interchangeably depending on, are you talking about a radio spectrum band, or are you talking about a particular use for a band that has been allocated for that particular purpose?
Is 900 megahertz in there?
It is, and we're actually going to talk about that with ISM here in just a second. So Common bands that a lot of radio enthusiasts deal with. HF bands are often used for distant communications. VHF, there are a lot of exceptions to this, but it's mostly line-of-sight communications. UHF is almost exclusively line-of-sight communications. A question that a lot of people ask, well, how far can I get on the radio and transmit? Or how far will a signal travel? Well, it depends is the answer. And it depends on a lot of different pieces here. Often dictated by the frequency, the antennas that you're actually using, the amount of power that you're using. There are exceptions to that, though. The location, the conditions on the ionosphere are very critical to that, as well as the quality of the receiver that you're actually looking at. And I've got a diagram up here in the top, and it shows a couple of different wave types and how it interacts with the ionosphere. So low frequency over here in yellow on the left, you can see that wave just kind of bends back to the Earth through the ionosphere there. Going up into HF and sometimes the lower ends of VHF, we're going to see it's going to go up a little bit further, and then it's going to bounce back down to Earth. Gravity. Yes, gravity. Exactly. We're talking about the higher.
That second one. But you can't make it.
When we're talking about VHF, UHF, and above like that, those will typically just go straight through the ionosphere. Now, there are conditions, say down on like the 6-meter ham bands, where you get a condition called sporadic E that you'll actually, you can actually bend those waves back down to Earth and work some long distances on some lower frequencies in the VHF band. That can occur. A lot of times when you're talking about HF, a lot of people also inappropriately include the MF, medium frequency band, in there as well. A lot of people just generally discuss HF as being everything from, say, like 0 to 30 megahertz. There are other bands that actually exist down there at the bottom of the spectrum, but they're usually included in when someone's talking about HF, so just be aware of that. When we're doing operations on the HF band, you get some weird frequencies that people will use like this. So something like this, 14.25746 megahertz, doesn't look real clean. You're using a VFO operations on HF band. So what you can essentially do is you turn a dial on the radio and take real small resolution steps, 10 hertz, 1 hertz steps as you're going through using the radio. And so it doesn't always land on some clean frequency when, say, you're trying to find a particular signal. Now, usually on VHF, UHF, you're using more channelized type operations. So as you're going through, picking out a particular frequency, it's going to be something generally evenly divisible by 5 kilohertz steps. So 146.520 megahertz. Your next frequency that somebody might be using might be 0.525, 530, 535, things along those are usually how those occur. There are other steps, 10 kilohertz steps, 12.5 kilohertz steps, 25 kilohertz steps. Sometimes go through, just depends on the particular region of the band that you're actually looking at as to what the next logical frequency would actually be. All right, industrial, scientific, and medical. So a lot of people are very familiar with this, and this is where your 900 megahertz stuff actually falls into. Originally, it was created for non-telecommunication uses. Was a license-free operation. Popular bands, there are several, but the ones that most people are familiar with, 915 megs, 2.45 gigahertz, 5.8 gigahertz. Like I said, there are other ISM bands that do exist. The most popular ISM device in the world is a microwave oven. It operates at 2.45 gigahertz. Does anybody know why it operates at 2.45 gigahertz?
It's up with Wi-Fi.
It's up with Wi-Fi. That's one answer.
And your purple phone.
The resonance of water molecules.
That's right. That's the resonant frequency of water molecules. So if you've ever put something in the microwave, like a piece of dry bread, and you try and heat it up, and you leave it in there for a minute, you pull it out, and it's like it's still cold. Nothing happens to it. And then you sprinkle a little bit of water on it, and then you put it in there for 10 seconds, and it comes out and it's burning your hands. That's why. So it's also the resonant frequency of our bodies too, being mostly made up of water. So that does what cause water molecules to vibrate. Is there's a gunplexer diode inside your microwave oven. that operates at that frequency.
So don't get in the microwave.
So, yeah.
Say that again?
Don't get in the microwave.
Don't get in the microwave.
So-
Bad idea.
So we can make ray guns. That's why it's not like you can
Feel free to put your keys, CDs, things like that, electronics, and in the microwave. You'll have a good time with
So like
that.
you hear stories of birds flying into a microwave. I don't know if that's,
It's a microwave.
is that a myth? If you
I don't know
microwave
that I
guns,
believe that, but you can get RF burns and things like that. I've experienced RF burns on Sweat Mountain.
Illegal Wi-Fi setup that kills some birds. So,
Okay. So you can do physical damage with RF.
like that.
Why
It
didn't
was
we
a myth.
choose 2.4 gigahertz for Wi-Fi then?
Because it's in the ISM band, that's why. That I don't know the answer to that
Because
question.
it's slowly drawing your brain out.
Now, these ISM bands are shared with other services, so there are other legitimate services that operate in there as well. The ironic thing about it is the ISM bands are now dominated by telecommunication devices, which is the exact opposite of the purpose that they were created for, such as 802.11, Bluetooth, Zigbee, there are others. Those are technically not ISM devices, but they're often referred to as that way, as the devices being an ISM device, because it actually happens to operate in the band. So common RF uses, I kind of just went through and created a quick list here of different users, different agencies, organizations, things like that, that may be going through and using RF for their various purposes. Obviously not a complete list there, but there's all kinds of different RF applications that exist. And like Keith pointed out when we started here, and anyone who owns an AP or they have a laptop with an 802.11 card in it, they own radios. So another important complex to understand is with simplex and duplex in RF systems. So we're talking about these different terms, simplex, half duplex, full duplex. In pure telecom sense, they're different than the way that they're commonly used in RF systems. So if we're looking in pure telecom terms at a simplex system, that means you're only able to send information in one direction. So that may be, say, you have a remote weather station that is sending its data to a base station who has a receiver to do that. Well, the weather station can only transmit, the base station can only receive. That would be a simplex form of communications.
Your TV.
Or your television, or broadcast radio is an excellent form of simplex communications. When you're talking about, in a lot of RF terms, though, it is used to mean half duplex communications, so back and forth, one at a time, but using a single frequency. So the pure definition of it versus the actual used form of it are two slightly different animals. Telecom, when we're looking at half duplex, that means one user can send at one time. So you have a two-way bidirectional conversation, but only one person can talk at the same time, or one device can only talk at the same time. When we're talking about it in RF terms, usually when you're talking about half duplex, and usually it's just referred to as duplex, is you're talking about split frequencies, and still only one party talking at a time, and the most common use of this is with repeaters, which we'll talk about in a second. With full duplex, the actual telecom term means that both parties, both devices can talk at the same time. Usually with RF, though, for full duplex, we're still talking about split frequencies, and both parties also being able to talk at the same time. Best example of this is a telephone.
Ethernet was originally half duplex.
That's correct.
Oh, yeah.
So repeaters. This is an example of a repeater site here. Usually you're going to find repeater sites up in high elevations, mountain tops, on top of tall buildings, towers, water towers, things like that. The purpose of a repeater is for retransmitting signals that it receives. It's going to generally provide you with a larger local coverage area that you might be able to get with a single device. So they're often used VHF and UHF applications. There are tons of exceptions to that, but typically it's going to be a VHF, UHF type of application. Usually they're going to be using a split frequency pair, so some type of duplex mode. Usually intended for handheld and mobile radio users. So one of the best ways to think about this is like a police officer. They're going to have a radio in their car, mobile radio in their car, and they're going to have a portable radio on them on their duty belt that they're going to be carrying around and using those radios. Yes, sir.
Those drums, those are directional, correct?
Yeah, so those are microwave links.
Right, so it's peer-to-peer between the towers and then the towers.
That could be one application for it, is if you are trying to do a point-to-point link for some application.
No, but I didn't know is if they were doing point-to-point between towers and then transmitting from there, or do you say those are picking up transmissions?
So usually those are going to be used for some type of a relay application versus these other vertical antennas on here are typically going to be used for more repeating type applications, where rather than doing a point-to-point application, it's one-to-many.
Most antennas have multi-use, multi-tenant. So it's not just one antenna is for doing all the repeaters.
Right. No, I just figured, I didn't know if you have one target that just takes all the signals, point to point, and then it transmits there, and then it sends it to the other point.
Well, there is
Like a mesh.
There is a case where they actually do that, and that's with television, where you have, for instance, a satellite comes down to the dish, goes to the local ABC affiliate, who then broadcasts it on essentially a repeater to the entire neighborhood. That is a case where they are actually doing that. But generally, that's not the case for radio communication.
Right. So when you're looking at repeater sites, you may have a dozen different entities with equipment in these two buildings that are up here. So, for example, I live real close to Sweat Mountain, and I used to go up there all the time. We had a club repeater that was up there. It's not there anymore. But as of this was even in like the late 90s, there were over 3,000 different frequencies in use at one site. And those were not all the same user. There's about a dozen towers up there, and people rent space on the towers. It's very expensive to get up on those sites, and there aren't that many of them. So they're very desirable.
And do any of them repeat camp?
Oh yeah.
Yeah, there's one on top of Stone Mountain.
Yeah.
See the proxy camp.
We'll talk about that. I got a couple of slides about proxy.
Like 500 miles away.
So one of the best ways to think about a repeater application is using low power devices as if they were a high power device. It's a real simple way, but it's a good way to think about how a repeater actually works. Because I can go around, one good example is I live close to Sweat Mountain. So I would go through and have this little Yaesu dual band radio here. And you can set this power down to this thing to 100 milliwatts. So we're talking about 1/10 of a watt. But then using a high gain antenna, me being about a mile away from the top of the mountain, I could open up that repeater full quieting, no noise in the background on anything, on 1/10 of a watt. And then you got guys who are out in their cars running a full 50 watts, and they're scratchy and just sound like garbage getting into the repeater. So, this is kind of a good case of an exception, running low power with a high gain antenna and being in close proximity, where I can literally, there's a spot where I walk my dogs through the neighborhood, I can actually see the top of the tower. A lot of different users of repeater systems. So repeater actually in use. So we see the repeater up at the top of a mountain here. We have disparate users using base radio, mobile radio in the car, portable user with a handy talkie here, all able to communicate with each other through the use of the repeater. Now the interesting thing to note is that we've got some terrain issues here. This user may not be able to talk to this user, that user may not be able to talk to that user by using simplex communications, trying to talk directly with each other, but through the use of a repeater, everyone can transmit on a uplink frequency. The repeater listens for that, retransmits it on a second frequency. That's where we get our split pair from, and that's our downlink then to everybody. So everyone listens on the downlink frequency, and then when they want to talk, they can transmit on the uplink frequency, and then everybody can hear them. So it may be possible for a user down here with a low power radio, 5 watt radio, let's say, to have the effective power of a couple hundred watts just due to using the repeater, and could say cover a substantial portion of the state, half of the state, is somewhat common with very good repeater sites. So moving on to your antenna system, and I want to focus on the word system here. It's often overlooked, but it is the most important part of a radio system. Now that can depend on your application. If we're just trying to talk between this room and the next room, your antenna is not all that critical here. But if you want to actually get out and get really good performance from a radio system, you do need a very good antenna system. System also includes the feed line that uses to transmit your signal from your radio to your antenna and vice versa. It's bringing the signal from your antenna to your radio when you're receiving as well. The antenna length is critical. So like for example, there's a diagram up here. It talks about the being a quarter of a wavelength on each leg of that antenna up there. And that's how you actually tune the antenna to the appropriate frequency that you want to actually use. There's a wide variety of antennas. So you going through and looking at just a vertical antenna here, quarter wavelength on the 2-meter ham band here for this particular antenna. We have got mag mount antennas. So these actually, it's got a big magnetic base on the bottom of this, would actually attach to your car. There are different portable antennas that you can use. So this is a portable kind of DC to daylight radio that you can use here. This one's kind of interesting concept with this guy. Is on the portable antenna here. You see the jumper on the side of it. And what it's intended to do is, using this jumper, there's a coil underneath of this. And if we go through and change the location of this jumper, we can short out sections of that coil and change the resonant frequency of this antenna and use it on many different bands here. There are dipole antennas, are very popular, and that's what this diagram is. In the upper right-hand corner here, where we've got our radio at the bottom, we have our feed line up here going up to a dipole antenna. That is a directional antenna. So we would essentially have coverage coming out from the screen and going into the screen. But then if there was something located on the ends here, or these nodes, you're not going to get that great of a signal. You may not hear anything whatsoever at all. A Yagi is another very popular type of antenna. This is a highly directional antenna, and you're going to get 2 lobes off of a Yagi. You're going to have a main lobe off of the front, which kind of goes out and focuses all of the power that you're using to drive that antenna in that front lobe. And you're also going to get a secondary lobe off of the back. So, but from the sides on it, you probably really won't hear anything at all when using the Yagi, unless you have a very strong signal, let's say maybe in very close proximity, then that may be the case. So those are examples of directional antennas. Where I started off here with just these vertical antennas, these are omnidirectional antennas, so they radiate outwards perpendicular to the antenna. So a good way to think of these is if you ever go and throw a pebble in a pond and you see the waves going out from that, that's kind of the same way that an omnidirectional antenna works. Common modes, protocols, and encoding. I sat down in about 5 minutes and just started going through different modes that I had either used or heard of. If I was to like really fill this out, it would probably take me several days to go through and look up every single one of them, and probably 5-6 slides, actually fill them out on here. The point being that I want you to get from this is there's a lot of different modes, and they're generally very well established, which can present some problems for these systems. And we're going to talk about that here a little later with some of these vulnerabilities. Far from being a complete list, just know that there's a lot of different ways that you can go through and actually operate a radio.
There is a Wikipedia page covering these too.
Okay, all right. Squelch and squelch bypass technology. So going through, and we talked about that the Earth generates its own RF noise. So you have a noise floor that exists at basically every frequency. And then you have a signal that you're interested that occurs at that exact same frequency. So you have your noise floor down here, and then you have your signal that you're interested up here. What the squelch lets you do is let you set a threshold in between the two that determine when the radio is actually going to operate and receive that signal. So if it's just hearing your atmospheric noise down here and your squelch is set here, it's going to take your signal being up here to actually break that squelch. So I'll give you a good example of it right here. So I've got, let's see here. Let me use this guy here. So I have my squelch set here on this radio. So what it's going to take for this radio to actually operate is a signal that is stronger than that threshold I've set with the squelch before you'll actually hear anything. Now, if I go through and adjust the squelch, now let me turn this. All right, if I go through and adjust the squelch, you can hear that atmospheric noise there. When I go through and tighten up that squelch, that goes away, so I've raised that threshold there that it's going to take to actually open this receiver up. There are other systems that are created for a squelch bypass. It does not use the squelch system, a traditional squelch system. With the squelch bypass technology, what it does is the radio is basically always receiving, but it's listening for some type of subaudible carrier. There's two different types really that are commonly used, but it's listening for those subaudible carriers before it actually opens the receiver up and produces audio for you. Ones you're going to see, PL stands for private line. That was a Motorola technology. CTCSS is essentially the same thing. Well, luckily, there's really like the three you see the most are right here: PL, CTCSS, and DCS. And these two are the most. These are actually the same thing, but they're sometimes used in slightly different ways. CTCSS, continuous tone-coded squelch system. We have the different frequencies here. You can see these are measured in hertz. These are all really low frequencies here. Also used in Europe. Some systems will use a 1750 hertz tone burst to actually open up a radio system. These were really designed, these bypass technologies here, to avoid interference. So you may have actually multiple users on the same frequency, but if they're using different subaudible tones, and say you're an infrequent user of that frequency, chances are you're really not going to hear each other using the radio at the same time. There's really no security to that. However, what you will see all the time, it is inappropriately marketed as privacy tones. People pick this up. Oh, this radio has 3,000 different privacy tone combinations. Well, they're talking about a combination between using a different frequency and then using one of these CTCSS or PL tones on there. So there's no confidentiality involved with that. You can listen to the conversation, and we're going to do a demo of actually breaking into a system like that here in a couple of minutes. You'll see, in like this can be defeated in about 30 seconds. I'll show you how to do that.
Basically, if any of you've ever taken a TV and you tune to a channel and there's no signal there, and you tune to another channel and there is a signal there, the security of the system is based on you going from channel to channel to channel to find out their signal.
Well, there's automated ways to do it as well. So I'll show you the automated way.
There's no security.
People don't have rabbit ears anymore.
So how secure is the system?
It's security, what?
Are you over the air?
Yeah, it is security through security. The thought being you don't know the code, but I'll show you how to scan for the code. Well, I got a slide for it, so let's go ahead and when we get to that part, we'll talk about that some more, and I'll actually demo it for you. There's two pieces that link together that I was going to demo to show you.
So I used to have a walkie-talkie that had a monitor button. And when I press the monitor button, I basically hear what I'm assuming now is the background radio. So is that basically lowering the squelch floor?
Yes, it removes it.
It just turns off your squelch.
Yeah.
Okay. That makes sense.
Yeah. So a lot of people use those to say you have a really weak signal that keeps fluttering in and out, and you've got your squelch set just at that point where it's just above the noise, and you still can't hear them, but then you hit the monitor button, and then you can hear them a little bit better. That's kind of the whole purpose of that function in a radio. All right, let's look at some RF gear. So radios that you can use. These are the two radios that I primarily use at home. This one's like 60-something pounds, so I decided not to bring it.
How expensive are those?
This one costs more than my first car.
By the way, that brand of
So these are both made by Yaesu. I have a lot of Yaesu equipment, some Icon stuff. I got another Kenwood HF radio. But these are the two radios that I use the most. And these are like ICOM has one that's $14,000 for a HF transceiver.
So is that software defined one that's like 7,000?
Yes, they get quite expensive. So when looking at radios, we've got a number of different form factors here. So I've already shown you guys a handheld radio, or sometimes they're called HTs, which stands for handy talkie. You have got a mobile form factor. So this is an ICOM mobile radio. So this would be like, say, mounted in your car. There are portable radios. This radio right here, this is another Yaesu radio. This is what that DC to daylight covers about everything. This guy right here, there's actually a strap, shoulder strap that goes with it, and it can be designed to either be carried around or used set up somewhere out in the field. There's another antenna connector on the back here that you could say if you wanted to throw an antenna up in the trees, you could go out and use a radio like that. So portable form factor here. And then the base form factors that we've got up here. I've got another base radio right here. Covers HF through VHF on this particular radio.
What is it that one does that's so nice? I mean,
we'll get to that right here.
Yes.
So different radio form factors, and you can have different radio types. So you have scanners. So this is made by a company called AOR. It's an older scanner that covers about everything. It's designed for going through. You program memory channels in here for what you want to listen to, and it quickly switches between those. It can also go through and search and do a number of other different functions, but typically it's not the greatest receiver in the world, but it covers a really wide range, and it can go through these frequencies very quickly, trying to find something interesting for you. A receiver, on the other hand, receivers can have memories similar to a scanner, but typically what you're paying for when you purchase something that's actually marketed as a receiver is the quality of the radio itself. They will have memory channels in them that you can go through and scan, but that's not really the intended purpose. So a lot of, say, shortwave receivers are built that way. We're going through looking for the quality of the radio, not the ability of the radio to go through, say, 1,000 frequencies in a matter of 20 seconds, let's say. A transmitter does the exact opposite of a receiver. It's what actually transmits signals. And you have a transceiver, which is a combination between a receiver and a transmitter. So let's just say ham gear is going to be transceivers. So all the equipment that I have up here, except for this AOR scanner, are all transceivers. So they have capabilities of transmitting and receiving. Now, what makes the difference between these radios? What's the difference between, so this radio is about $600 or $700. What's the difference between this one and the one that's $14,000? Buttons, yeah. It certainly has more buttons and knobs, and that's the only difference between the two radios.
I see some
A better screen. It's got a better screen. That's where you're.
I want to ask you a quick question.
Okay. Sure.
I'm going to say, or I'm making assumptions here, that with receiving, does it solely rely on the transmitter of how well you can receive?
No.
Where does your antenna come in play with
It's
that?
your most important. Well, to a certain degree, it's the most.
Transmit when it comes to power versus with receiving and transmitting. Is there?
I got a slide here in a couple minutes that talks about this. But I'll go ahead and answer your questions. So you got to leave.
Well, no, I'll wait. I can wait.
Okay. All right.
I know,
Okay.
like 10, 15 minutes.
Okay, so here's where your price difference is going to be in a lot of your radios, is in these two functions right here. So the two words up here are sensitivity, which talks about how faint of a signal can that radio actually receive. So a lot of the times when you're trying to pick up distant signals, they are way down in the fractions of a microvolt is what actually occurs on your antenna to be able to listen to some of these signals. And the more sensitive of a signal you want to, or the lower the signal you want to be able to pick up, the more sensitive your receiver has to be. To get that additional sensitivity, you have got this curve that goes like this. where, yeah, I can pick up all kinds of stuff down here for a few dollars. But if I want to come and pick up just a little bit more, my price is going to jump through the roof on being able to purchase that equipment. Your selectivity comes into where all these buttons, a lot of these buttons and knobs comes from. So your selectivity discusses how able is the radio to pick up and pull out one signal if you have two adjacent signals or many adjacent signals. So we've got two signals that say maybe only a few hundred hertz or maybe a kilohertz apart, and I'm only interested in one of those. How easily can I go through and make modifications to the signal that I have received to just hear that one particular frequency, one particular signal? And that's where a lot of these buttons come into play, is going through and you have like digital signal processing built into a lot of your radios. There are filters that are built into the radio, so it's a band pass filter, so it cuts off signals that are below what you want to hear and above what you want to hear. There's what's called IF shift, which actually you're still on the same frequency, but it can slide the window of what you're looking at on that particular frequency. So you have a very quick point of diminishing returns. There's a lot that you can do with a really cheap radio, and spending $10,000 on a radio versus say $1,000, it is not a 10 times better radio.
Modulation types as well.
Well, yeah, so most of these are all-mode transceivers as well. And yeah, all of my HF radios every single one of them is considered to be an all-mode transceiver. It's fairly common these days, although there are still a few brand new ones. ICOM has one called 7200 that doesn't do FM. That's the only one that I'm familiar with that doesn't, is not considered to be an all-mode transceiver. All right, software-defined radio. I did a whole hour and change presentation on this before, so we're going to try and cut this down into like a couple of slides. So what we're effectively doing is, before, when we're looking at these radios, the majority of your RF processing is done through hardware. There is some digital processing that goes through here, where you have an analog to digital converter. You go through and process the signal, and then you have a digital analog that's sitting right in front of your speaker. When we're talking about SDRs, we're moving most of that processing off of hardware, and we're using software to go through and do that. So typically we're using, say, a CPU and a computer to go through and do that. There are some SDRs that have like FPGAs on them that can process a little bit on the radio itself. But the advantage of this is we can go through and substantially reduce the cost of the hardware. Now, there are still very expensive SDRs. So like this one, which is for HF, it's still $500, but it's a lot cheaper than purchasing a comparable HF receiver or transceiver with the same capabilities as this SDR here. It's all digital processing. Effectively with these, most everyone's familiar with these little Realtek New Elect dongles here. We can take about $500 or so worth of radio hardware and bring it down to 20 bucks.
Assuming you have the $2,000 computer to play.
Assuming you have the computer, yeah, just to play with it. But most of us should already have that equipment. And these were really based on actually a hacked TV receiver. So they came up with a chipset that was designed for receiving digital television. And somebody started looking at the capabilities of this chipset and thought, well, wait a minute. They've essentially taken this really robust chipset with all kinds of capabilities and put a governor on it. Is essentially what they did. They said, okay, well, let's like remove that governor, and now all of a sudden we've got a receiver, a very capable receiver here on a cheap chipset here. Some popular pieces of software you can run to control these: SDR Sharp, HD SDR, which is what I use an awful lot. There's the GNU Radio, which is a whole suite of different applications for doing SDR work. Specifically within that suite, there's the GNU Radio Companion. And we're going to talk about that here in a little bit more. If you want to give it a shot, get the latest Pentoo Linux distro, and it already comes with those packages already in the distro.
Do you know if Kali comes with some of those as well?
Yes, you can download them with the correct command.
Yeah, Kali 2.0 is coming out of DEF CON.
Yeah, that's right. I saw that. They are susceptible to computer noise. So I have another one here that this is the latest version of that guy there. It comes in a blue case, but I bought an actual enclosure for this to help shield it. The other thing that I do is I have a 1 meter USB extension cable that I use to get this away from the computer a little bit. So you can go through and shield these. So some other versions of, well, let's talk about this first. So when we go through and we're talking about all the different components that occur in hardware in a normal radio. So this is one of the radios that I use, and this is a block diagram from the sales brochure from it. You can go through and see all the different steps that it takes to go through and process an RF signal to turn it into audio. Well, with GNU Radio Companion, here is an example FM receiver. So you're using let's say a $20 dongle here. We're going to go through and replace that block diagram in software. Well, what GNU Radio Companion does is it takes this block diagram, basically turns it into Python commands, and then runs the Python script to go through and actually perform all these functions that would normally be implemented in hardware. All right, another really good one worth mentioning here is this Hack RF1 from Great Scott Gadgets. Michael Ostman created this. It's I've got the specs here from their website, some of the ones to look at. Covers from 1 meg to 6 gigahertz. So this is like a true DC to daylight kind of radio here. It is a half duplex transceiver. So when you're going through and you're looking at the real inexpensive Realtek dongles, these are receive only. This guy right here will actually transmit as well. It's very low power, but with using an amplifier or a high gain antenna, there are a lot of other applications that you can do with that. It's also open source hardware. So if you want to go through and tinker with it, you are more than welcome to go through and do that. These are $300. All right.
It's dirt cheap.
Yeah, for the functionality that you're getting for $300, that is a steal.
What's the general ratio for like SDR to like normal hardware? So say like if you buy an X dollar SDR, like what does that compare to? Like,
So that can be kind of like a Ford versus Chevy discussion, depending on the radio that you want to get. Because when you're looking at, say, hardware radios, you can have a radio that's multiple times more. But when you start looking at all the specs side by side, you're like, this is pretty much the same thing. So that's why when we were talking about it, I said, this $20 dongle is $500 plus. I can't really think of a good way to come up with a coefficient to try and map that out.
Most of the hardware stuff was offshooted with the SDR to an application. So
Yeah.
What is the benefit of having hardware? Because computers sometimes stuff.
Well, so I'm actually interested in using these radios for transmitting as well on ham bands. There are software-defined ham radios as well that will transmit. So there are, say, like 100-watt transceivers, which is a common power in ham radio. I like having this form factor of having buttons and knobs and screens and stuff like that to actually play with. I like being able to have a mobile form factor in my car that I can go through and use without having to worry about like taking my laptop out of the car every night. I like having the ability to have a portable form factor that I can drag this out of the woods.
So it's form factor primarily.
In multitasking.
Yeah. Yeah.
Well, part of the difficulty, if you start to get into RF, it's like with computers. If you ask somebody says, "What's the best computer to buy if I'm just getting started?" Well, the problem is you don't know the right question to ask to figure out what the best computer is for what you're doing. So the best thing to do is get something cheap and simple to start playing with it, to learn the terms and terminology, and find out what it can't do. And then you say, oh, I want to do that, and then go find something else that will do that. And so it's part of the learning curve, and that's the advantage of the SDRs, where it used to be, example, when I got started, a decent ham shortwave receiver was hundreds of dollars. That's just to get started with just a receiver. With an SDR, you can do everything that almost all of this stuff collectively can do for $20, receive only, and play around with it on the computer you already own. So it allows you to get your feet wet and learn how to do it, learn the terminology and the technology, and then when you figure out, oh, but I can't do this, then you can start looking into what I want to buy to fix that function. In some cases, it might be a $300 hack RF, and in other cases, it might be a $14,000 Yasuo. So, yeah.
I also feel like there's definitely a nostalgia factor for some of this stuff.
Yeah, I
I just bought a record player yesterday.
I will
You know, it's
guess.
like, I have, they're called record players because of these
Oh, they're starting to make new ones.
things. And yeah, it's like I just basically bought a whole bunch of albums. Yeah, well, I'm not a hipster or anything, but well, no, it's just like, you know, I just rebought all the music that I rebought on
Now, I will.
MP3s. I bought it for the 4th time. I went from vinyl to tape to digital back to vinyl.
I will say, in practice, an example of HF and UHF, the Gemini missions, when they first started doing space flight, I would listen to them on an HF radio. And it took me a while to find the frequency, but I found it. And whenever they were in your hemisphere, you could hear the astronauts, but you couldn't hear the ground station. So you heard half the conversation, half the time, because when they're on the other side of the planet, you heard nothing. Well, then they went to Apollo, and I had to sit out in the garage with my receiver, tuning through all the bands of a 7-band receiver by hand, because if they're transmitting at the time you're on that frequency, you hear them. If you're scanning, if you're tuned on some of the frequency, you don't know they're there. So you have to patiently, hour after hour, scanning manually through the frequencies, looking for this transmission, only to find out later that they moved from HF to UHF. And I didn't have a UHF receiver. Yeah. So actually, how I found out, I got a model, a Revell plastic model, glued together model of the Gemini capsule, and then it was a form to send away to NASA to get on their mailing list. And one of the brochures they sent me on the mailing list was explaining the new radio communications for the Apollo mission was UHF, and I was crushed. I just ruined my whole day. Well, here's the fun thing. With a software-defined radio, you can see the whole spectrum at one shot. Finding that guy is like trivial. It is so much more easier to deal with.
Or you can let it run and record over the spectrum too, and then go back and play it later to try and find it when you get home from work.
So nostalgia is cool, but it's a real pain in the ass.
It's very direct. If you could go into outer space very far away, you could still pick that up.
Yes, except I'd have to travel faster in light to get ahead of the wavefront.
According to science fiction, I mean, once it does kind of
You gotta be on the
As
other
the
side of the
signals get
universe.
going, they get reflected. It's eventually going to diminish. My guess is it's eventually going to diminish.
Well,
I don't
the
believe
wavefront energy, the energy of the wavefront eventually drops below the threshold noise for the universe, and then it's indistinguishable.
Well, whatever. I have my imagination. You have your theories, I have my imagination.
So like I hear that, like, you know, like Hitler was the first thing of the transmitter or something like that.
For this.
Right, so if like I'm out like past Pluto, what are the chances I can actually pick up Hitler's dog?
You gotta go further
Because I
past
love it.
Pluto.
Yeah.
It's already, it's
So
already
you're
past
moving
Pluto.
300 million
You got a
meters
pro
per
out
second since what,
Like
1937, 38. Yeah, it's
like-
quite some distance.
No, the quick, oh, okay.
You're an interstellar.
You have to go through the black hole first.
Yeah.
Well, no,
Light
okay,
speed.
so there's aliens out there. I'm serious. What are the chances they're actually?
I don't know a lot about that aspect.
You don't know about
My guess is it's about. I know
What kind of expert are you?
Yeah, I don't know anything about this stuff.
Well, we know, but we can't tell you.
I'm sorry, we've
So then
got
why would you use setting and try to figure them out? What are the odds actually?
Very low, because at some point the wavefront, think of it as a balloon, and as it gets bigger and bigger and bigger, the energy is on the entire surface area of that balloon. So that means the energy gets lower per cubic or square centimeter as it gets bigger in radius. Well, at some point, the natural noise of the universe is stronger than the energy on the surface of that balloon. You just can't pick it up anymore.
So then why do we bother? I mean, I know this is all public.
So one
Yeah,
perception is
Yeah.
I'm sorry, we're up. Right?
That wasn't a directed signal. You can do a directed signal. You can encode it in ways that makes it less susceptible to noise. But at some point, it's going to
I
die.
got 59 more slides to go.
Yeah.
All right, I'm gonna pick up the pace a little bit, and we're gonna get to your question on the next slide. Okay. All right. TNC, it's terminal node control. I got two versions of it here. The first one's implemented in hardware. Second one's implemented in software. This one allows you to encode and decode digital signals. They are very handy when you're looking at non-analog signals. All right, amplifiers. So here's your question right here. Amplifies the power of a transmitted signal. There are other things such as LNAs, low noise amplifiers, which are used to improve the reception of a particular signal. But when most people talk about amplifiers, this is what we're talking about. Output ranges of an amplifier, depending on the band that you're on, can range from fractions of a watt up to several thousands of watts. And we're going to show you an example of that here in a few more minutes. All right, here's the real question down here. Use a better antenna before you use an amplifier. Or another way to say that is spend more money on a better antenna before you go out and purchase an amplifier. Is really the name of the game. So one of the aspects of ham radio is called QRP, which is low power communications, which is actually what this whole radio was designed for operating on. So this radio runs on 5 watts, no more. You can actually knock this down to, I think, 500 milliwatts. You're talking a half a watt you can knock it down to. With a proper antenna, conditions, location, operating frequency, modes, things like that, it is possible to work a couple thousand miles on a couple of watts here.
Really?
It takes some effort to do, but it can be done. It is very common with, say, using 5 watts to work several hundred miles. That is very common.
When you say the proper antenna, you're talking about. I know. Is it when they say, well,
so
bigger the antenna?
That's a really good question. That's a really good question. So probably the best antenna that if I had unlimited funds would say be to put up about a 150-foot tower and put a multi-band Yagi up on a rotator that I could then move that around. That's going to cost a boatload of money to do. Right. The next best thing that I can think to do is to purchase about a $50 dipole, or say a G5 RV or something like that, and get that way up in the trees.
So when you're transmitting a fraction of a milliwatt, like if you attach that to a 500-foot radio tower, isn't it going to, is it the ammunition going to, is it just going to kind of die off?
So you can get gain,
more power
you can get forward gain from an antenna, and that gets into what's called effective radiative power. So where it's like your transmitter's only, say, 10 watts, but if you have like a 3 dB gain antenna, all right, well, that turns into 20 watts effectively at that point in time. So there are ways to go through and do that, but having a properly tuned antenna up at a good height, if it's directional, facing the proper direction, using the proper frequency, having a good receiver on the other end, there's a lot of factors that play into that. Versus just how much power you're actually running. So most ham radio transceivers, this is HF, VHF transceiver, this runs at 100 watts. That's a very common rating. Most of your mobile radios run from somewhere between 50 up to a couple of them run up to 7 watts. Most of your handheld stuff is about 5 watts. But this is, again, it's handheld stuff mostly for local type communications.
Why would you want an amplifier that only outputs a fraction of a watt?
If you're using a particular frequency that you've got a real high gain antenna, so stuff up in the microwave range, you may not need more than that.
And there are limits to how much power you can broadcast on certain frequencies.
Yeah.
And it's effective power, not necessarily real power.
You're very welcome.
And so you have to pay attention to that. For instance, with directional antennas with Wi-Fi, it is possible to exceed the effective power that the FCC limits it to.
Big brother.
Yep. All right, ham radio. So this is one of the sections where I went through and put out an enormous amount of content from what I actually wanted to share. But this gets you into an uber nerd factor right here. So how many hams are in the room?
Quasi-ham here.
Quasi-ham. All right, we got a few in here. But would you guys agree that this gets you into the uber nerd factor?
Yeah.
All right.
Hackers of old were ham radio guys.
Yeah. You get a lot of engineers who are ham radio operators. I have a background in electrical engineering.
Ham radio operators pretty much designed a lot of the cellular networks.
That's true. There have been a lot of technologies that have come out of ham radio as well. It really operate that well or that way anymore, but it used to be. Hams were pretty much at the forefront of RF technology. All right, so ham radio. I'm going to try and cover all of ham radio in this one slide here.
Oh,
so, and go. You've got 3 different license classes. There used to be at one point in time there were 6. There's study guides available that you can go through. The FCC, which is understand so the question you have a full kind of stuff in these and for about Amazon for about $25 a piece for $25 for each manual for the different license classes, and it's a progressive system. You get your technician class first, then you get your general, then you can go and get your extra class license.
Is that what you have?
So I have a general license, and I've got the book for the extra, so I'm probably gonna do that in the next couple months.
Is there any purpose in getting the top tier? Well, what is the purpose of getting the top tier license?
So it gives you more portions of the ham bands that you can cover. And usually what you're going to find with, when you go through and you look at the ham bands and where they're divided out, which license class can use each segment of it, typically your what's called a DX window is going to be at the lower end of the band, which happens to be where extras get their additional privileges from. And that's where if you're going to go and be working a lot of foreign stations, typically they're going to be operating down in that portion of the band. So if that's your interest, is going and talking to a lot of foreign stations, which is a very common aspect of ham radio, you're going to need an extra class license to be the most effective.
Also, ACT Radio here locally carries a lot of AARL or
Yep.
ARRL.
ARRL.
Yeah, names.
Now, this is an interesting aspect. There are more than 700,000 hams in the United States. There are more hams today than there have ever been in the history of radio, which really surprised me hearing that, thinking that, okay, well, everyone's hopping on the internet and using that for communications and messing around with stuff. Like ham radio is just going to go by the wayside. And in fact, the exact opposite of kind of that prediction has occurred, where there are more hams today than have ever been. There are dozens of avenues of focus. We've talked about a couple of them, like QRP, building equipment, portable operations. There's even a mode that only a handful of people do called EME, which stands for Earth, Moon, Earth, where you literally bounce VHF signals off of the moon to return back to Earth using high-speed, several hundred word a minute recorded Morse code for your communications.
And a big ass parabolic dish.
Yes, yes, it requires a lot of money to get into that.
Yeah.
Whole purpose on ham radio, you can communicate with other hams locally using, say, VHF, UHF communications around the world on HF communications. And here's the funny part. So hams go out, they study, they get a license, or they buy the book, they get a license, they save up, they buy equipment, they figure out how to set it up, they may build their own antennas. What do they use ham radio for? They get on and talk about the equipment that they just bought and the antennas that they just put up, and they also talk about computers. This is, I promise you, this is about 90% of ham radio is getting on there and talking about ham radio.
So it's a radio version of IRC.
Yeah, it's a radio version of IRC. That's right. One of the unique things that ham radio allowed me to do was there was an interesting trip they got together in 2001. It's the only one that's ever been done. There were 18 people that went on the trip. 11 of us were hams, so I'm one of 11 people that have ever done this. We did an exchange program with Russia where we actually went over and stayed with Russian hams. So I went to Moscow and St. Petersburg for 2 weeks and went over and I got to do a lot of interesting stuff. So I went to the Cosmos Museum in Moscow here, got to operate a little bit over there. One of the things we did, we went to a little town a couple hours outside of Moscow called Zelenograd. And there was a radio club that runs in Zelenograd. And we went in and they showed us their station. We were really impressed with that. They have modern transceivers down here. This is an ICOM 756 Pro 3, which was very current at that time in 2001. And we go in there and we start operating. And I'm using this radio here, and I'm making contacts, and me having an American call sign operating over there, I was like the rare one to go out and get, and everyone's like jumping on, trying to work me on the radio. Well, I'm sitting in this chair, and one of the guys who's from this station leans over to me, and he says, "Oh, if you want more power, hit the foot switch." So down here, you can't see it. There's a foot switch down here. Well, that foot switch controls a relay in the back of this guy right here. This is a Soviet surplus amplifier, and based on the size of it, our guess is somewhere between somewhere between about 10 to 15,000 watts. Now, this is more than some commercial broadcast stations use. This is not legal to use in the United States, and I'm not sure if it was legal to use in Russia or not. But it was Russia. One thing you'll notice here is through this grate, see the glow that's right? That is a tube that's being used as an amplifier, and that tube runs all the way down to about here in there. And when I hit that foot switch, the lights in the building dim, and a few seconds later, the ambient temperature in the room went up by several degrees just by operating this giant tube that's inside of the cabin here.
And you'll now have cancer. So.
Probably not. I didn't use it that much, but so that's what they use over in Russia with some old Soviet surplus gear there. The other thing we did, we went to the man who owns this. This is his dacha or his summer house. A gentleman named Andy Chechnikov. So this is not his house. This is this guy's summer house, and you can see his tower here. He's got a handful of Yagis, parabolic dish on the roof there. And actually got to go through and actually operate in his station. He's real famous for going out and doing what's called a de-expedition, where they take a whole bunch of gear, they put it on a plane, fly to some remote location, get on a boat, go out in the middle of nowhere, some area that has its own zone that nobody ever operates from, and then they bring that up, and over, say, 10 days, 2 weeks, they'll go out and make 30, 40, 50, 60,000 contacts from one particular location, just running around the clock. And that's what this guy is known for. Well, not this guy, but the guy who owns this is known for.
Sorry, I don't understand that. You're saying you go out to a remote location and begin communicating with other people.
Right. So they would go through
and communicate with them from the comfort of his summer.
So there's a lot of contesting that goes on in ham radio, and you're going out and trying to collect contacts from unique locations. So if you have a unique location that no one ever operates from, it's about impossible to go through and get credit for that unless somebody actually goes out there and does it. So it's a form of contesting. So what they will do is they'll contact the governing body, and they will get a call sign for that particular location, go out to that location, operate from that, and then you can get credit for having worked someone in that particular location.
So you know where someone is, though. How do you know that?
They announce it beforehand, like years in advance on the internet, that they're going to be going to do this de-expedition at a location. Okay. So then when they get there, sometimes you'll have somebody back wherever they came from, posting information online, real-time information. Hey, they're going to be operating on these bands near these frequencies. Go find them.
So there was a go to a new location, you pick up a new call sign for that location.
That's like a 30-minute conversation. When you're leaving countries, yeah, it's going to change. Like when I was operating in Russia, I added R3 onto the end of my call sign to denote that I was operating in Russia. When I go up to Canada, I operate up in Canada, and I add VE3 to the front of my call sign to denote that I'm operating in Ontario when I go up there. And I take a rating.
So it's your IP address for ham radio.
Yeah, yeah.
So if I were to say, like, go to the moon, I would, like, if
I don't know what the governing body
for a chance I actually get to the moon, I can put something on my call sign and then deep down.
Well, actually,
everyone will call me a liar because there's no way I'm on the moon.
Sure.
So, well, there used to be I assume it's still there, a famous Mars station in Antarctica. And so you would talk to them, and then they would actually mail it. If they connected to you, you could prove it because they mail you their QR code, QSL card.
So this is the one I
from
got
the station saying when they contact you, so you actually have proof you talked to them.
Yeah.
Station or the guy?
The guy who owns this, Andy Chechnikov, that's his QSL. So yeah, if you're going out to some particular area outside of your country, you can apply for a call sign to use there. Or there are other ways, such as adding a prefix for that region onto your call sign to denote that that's where you're operating from. So like when I was at Rush, I was /R3, and people knew that that meant that I was with Russia.
Yeah, I don't want to go down a rabbit hole here again, if this is a problem, but like you say, you have a call sign, and you said that's like your IP. Is that really like your IP, or is it just more like your nick? Like you can just change it?
No.
No, you can't change it.
It's a
Well,
license.
yeah, it's a license for you to go and operate. It's going to stay static unless you apply and go through a process to get that changed. So when I was first licensed, my call sign was KF4, which denotes that I was in southeastern United States. OEG was my original call. And then when I went through and actually upgraded my license, I applied for a vamping call sign. So I got one that I was able to choose, which is K4BRG. The format of your call sign can denote your license class as well.
Yeah.
But most people, when they get one, they keep it for a while. So it's not something that's going to change just because, instead of operating from home, I'm now operating in Manuel's Tavern today. It's not going to change like an IP address would, but it effectively identifies you.
And that identification is something that you can prove that you have the right to speak. Like you won't be arrested, is what I mean?
I don't know if anyone's going to be arrested for that.
Other hands will come down on you.
Yeah.
And glare at you very, very
We sell it
sternly.
self-governing.
The FCC, if you're way out of line, the FCC will come after you.
Yeah.
Okay. It's more about like it's your authorization to speak.
Yeah,
Yeah.
WS,
Yeah.
when you hear
The license.
WSB TV, that's a call sign.
Okay.
Yeah, we're gonna, well, actually, that's another, never mind. All right, vulnerabilities. So there's we've kind of gone through, all right, a little bit, how does all of this stuff work? And once you understand how all this stuff actually works, that's when you get into some of the more interesting stuff here. So common weaknesses. Still lots of analog signals exist. Very easy to receive, sending information in the clear. Established digital protocols and encoding without encryption. So remember that slide way back where I had a list of different protocols and modes and encodings that I had actually used. They're well established. The equipment to go through and decode that stuff, especially now with SDR, you can just go and download the library for that, plug it into a GNU Radio Companion, and then you've got the proper decoder built in for that particular protocol. Almost no authentication, and when you do see it, it's expensive as can be. Vulnerable to hijacking attacks. Signals can be easily jammed. Changes are slow and expensive. So let's say somebody goes out and spends $10 million on a radio system, and then all of a sudden they realize, well, this thing sucks. Are they going to go and ask for now $20 million to go on top of that? No, you're going to be stuck with the $10 million piece of crap that you bought. So then they're just going to be sitting on that for forever. It's expensive to properly secure. So Motorola does offer AES encryption modules for their radios. We're talking several $1,000s per radio. So you can imagine, say, being a county and trying to purchase hundreds of radios at $5-6 grand a pop. This gets very expensive very quickly. There's a lot of use of security through obscurity. We talked about the PL tones earlier. Oh, wait a minute, the package said this. This thing has got all kinds of security features built into this. Well, no, really, it's just to avoid interference. That's really all it's there for. Or they may go through and use code words on the radio. So this is very common. You hear a lot of law enforcement using this. And sometimes some schools thought, okay, they're using the codes to obscure the meaning. Some of them they're using the codes because it's faster. If you have a bad reception, they may be able to understand a particular code used versus, say, you just spelling out in clear text exactly what's going on. But if you go through and you're listening to, say, a particular group, and every day at noon they say, oh, I'm code 12, well, what do you think that means?
Lunch.
I'm going to lunch. And then 45 minutes later they say, all right, I'm code 72. I'm just making numbers up here. I'm code 72. What does that mean?
I'm back.
I'm back from lunch. Okay, how hard was that to figure out just by listening from a couple of days? Pretty easy.
We said that it's expensive. Can you do SDR to make it cheap? Can't you encrypt it and then send it out?
Well, if you want to be carrying around like a laptop with an SDR and a microphone, for your radio product.
Raspberry Pi.
Think
Raspberry Pi.
Yeah, how do you put a Raspberry Pi do as an as a computer?
Oh, I'm glad you asked that. There's a slide about that at the end of the presentation.
When does that become illegal though? Printing your communication.
Well, so over ham radio, there's only one time that it's okay to obscure your communications, and that is control signals to satellites. That's the only time. For other purposes, I really don't know.
Like neighborhood police radios, that's a different thing, but is that
Well, they're going to be purchasing professional like Motorola or Harris equipment for going through and doing that, and they're going to be licensed to be using those frequencies. So if like we wanted to set up, let's say, our own radio network and encrypt the communications, no, we can't do that.
So I heard that there's an exception as far as like if you're, because people actually do set up IP networks over
Right.
where if you are on an IP network and like some piece of content, like I go to google.com on
Right.
my IP network and it's encrypted over SSL, then that may also be an exception.
Yeah, I'm not that familiar with that exception, so I really don't know. I'd have to look it up.
The laws are very, very slow to change.
Yeah. Common weaknesses that you're going to encounter with a lot of radio systems: information disclosure, loss of integrity, denial of service conditions, all over the place. CIA is gone. I'm glad you brought that up. We're going to talk about that in just a second.
There's an array,
So-
we were talking about that.
Detection methods. All right, if you want to go out, you want to find the location of a transmitter, there's a number of different ways that you can go through and do this. Now, as an individual, it's very difficult. If you have boatloads of money and you're a three-letter agency, that kind of goes away, but I'm not a three-letter agency with boatloads of money. So if I want to go and find the source of a signal, I can use radio direction finding. Port OPSECs can sometimes go and give that information away. Hey, I'm interested in this radio system. I'm going to go and like figure out where the radio manager goes to lunch and get the table next to him and listen to him bitch about his radio system and all the problems that he's having and learn all kinds of information. Visual methods, just looking for antennas. Triangulation. All right, that's a whole gigantic discussion right there. But imagine we have a map. And we know that somewhere on this map there's a transmitter that we are interested in. Well, I'm going to travel to these different locations on this map, and I'm going to go out there and take some readings. I'm going to use some directional antennas, and I'm going to find the direction that the signal is strongest coming from. So let's say I come down here, and I got a real strong signal coming up here. And then I go over here, and I got a real strong signal coming up here. And then I go over here, and I got a real strong signal coming about right there. Well, I'm going to go and find where all three of those paths intersect, and that's going to get me real close to that transmitter site. Now, once I'm there, there's a number of different things you can use. Doppler DF, which is, there's an example of one of the systems up there. It's 4-phase antennas, quarter wave antennas, spaced a quarter wave length apart. And essentially what the Doppler DF system does is it rotates through those antennas very quickly. It jumps through phases of those. And you listen to the output of your receiver here, and it tells you where the direction of the strongest signal is coming from. So you can literally drive around and watch which direction this is coming from and keep driving around in circles or going around in blocks, and you can eventually figure out exactly where the location of the transmission is coming from. Using directional antennas, we talked about, there's an example of a Yagi there. So we're going to be looking for strong signals coming off the front or sometimes maybe even off the back of that antenna. We can go through and use adjacent frequencies if we get very close to something. So if we have a signal, let's say it's at 210.2 megahertz, well, maybe I'm going to turn it to like 210.25 megahertz. And as I'm moving off a frequency, I'm only going to hear something or detect the signal as I'm actually getting really close. Another thing you can do is use attenuation. So most radios will have an attenuator in there, which essentially is like, say, a 6 decibel or 12 or 18 decibel drop in the signal that you're going through. So it's going to take the signal you're receiving, reduce the power of it by several fold, and by using that, it's going to help you get closer to finding the source, because now you're looking for very weak signals. And then all of a sudden you sweep across something and the signal strength really increases. You know you're getting right on top of it. There's a body block method. So if you have a radio, and this usually works well with 2 people, you can hold the radio in front of you and then watch. So like this particular radio has a signal strength bar on it. If I have this in front of me and there's a transmitter behind me, it's not going to be able to receive that very well. As I start to turn around here and someone's moving around with me, keeping pace with me, when they see that signal strength meter go up, they're going to know that I'm facing the direction of that transmitter. So there's another method you can do that as well. People make contests out of this. They call them fox and hound contests, where they'll run around with equipment like this and they'll hide a transmitter somewhere and literally make games out of going through and finding these hidden transmitters. So there are people that are very good at this. It's kind of similar to like orienteering. Yeah, yeah. Avoiding detection. Okay, so move around. So be mobile. It's hard to go through and do this triangulation on a map if when you're down here and you're getting a signal from over here, and then when you come over here, now your signal is off of the map, and it doesn't make a bit of sense as to what you're doing. So someone who is on the move is much harder to detect. Be discreet, kind of like this van here.
Yeah, that's real discreet.
Very, very discreet van that they're using right there. Keep your transmissions short. Most of the detection, all of the detection methods are relying on the fact that you're still transmitting somewhere to be able to detect your direction. Don't transmit on a schedule. So don't all of a sudden fire up your pirate radio station at 4 p.m. every day. Because if someone gets closer and closer, they're just going to go at about 3:45 to the last place that they went, wait for you to fire up at 4 o'clock, and then they've got another hour to try and find you. Do not interfere with commercial sources. This is huge right here. The FCC does a so-so job at people doing bad things with radio, but if you are interfering with a commercial source, someone who is paying them a boatload of money to operate and have that license, they will come down on you very, very quickly. Use directional antennas. So let's say you're out there doing something and you're using an omnidirectional antenna. Well, that's going to be a lot easier to track than if you're operating with a directional antenna and say that signal is pointed at a mountain and is then reflecting off of that mountain. You're going to get scatter all over the place. Or if you're operating near water, RF does all kinds of weird things when you operate near water. It can literally, you can be next to a river operating and somebody 100 miles downstream, it can sound like you're standing right next to it. All right, this is real interesting here. RF-based CVEs, there's a couple. This is really one of the only times that I'm going to talk about like Bluetooth here. First one, this is from TrustWave, the Lixil Status toilet. They reverse engineered the hardware, the firmware on the Bluetooth controller for this Lixil Status toilet. It's a Japanese company that makes these $5,000 toilets that have apps for them to be able to remotely control your toilet. TrustWave found a hard-coded Bluetooth pin. Attackers could cause the unit to unexpectedly open and close the lid, activate bidet or air dry functions, causing discomfort or distress to the user.
Or flooding your bathroom.
Or flooding your bathroom.
Started squirting me when I didn't expect it to. I'd be highly distressed.
Well, don't buy the Lixil Status toilet. It's got a hard-coded Bluetooth pin without getting the firmware upgrade on it first. Boosted board skateboards. This one was fairly recent. It's a 2015 CVE. This came right off of NVD here. Physically proximate attackers to modify skateboard movements, cause human injury, or cause physical damage via vectors related to an injection attack that blocks and hijacks a Bluetooth signal. This one down here is a very good example of illustrating my point about how slowly things can change in RF systems. Package called Node, privately disclosed RF denial of service vulnerability in 2005. Somebody found this in 2005. Privately disclose this to whoever maintains the package. And essentially what it is if somebody is using Node, which allows you to do IP over a ham radio here on a Linux system, if they improperly leave a telnet session, it's going to keep that socket open and keep sending signals back and forth here over RF and can DDoS a remote site here. You notice this was assigned a 2015 CVE, but it was actually privately disclosed in 2005.
So
10
it didn't
years.
get,
Okay.
it hasn't been fixed.
I don't recall the solution, but I believe this has not been fixed.
Stop using it.
All right. If we were to go through and treat this like a computer system here, most RF systems fall under a base score of 10 and temporal vectors of 9.5. We're looking at remote access, low access complexity, no authentication in the vast majority of cases, complete loss, confidentiality, integrity, and availability. It's known to be a functional exploit. No fixes for it other than purchasing a multi-million-dollar Motorola system, but that still only corrects a little bit of your issues here. And report confidence, I can confirm that this stuff works. So if this was a computer system, you probably wouldn't be using it.
Well, I mean, I don't recall anything about the system against us, but you know, like the first two could kill someone or hurt someone physically, right?
Sure.
Which, you know, most attacks the web or their inconveniences, you know,
Right.
you get rooted on your machine. But these, the skateboard one, at least you could seriously.
Oh, sure. Yeah, if you were, you know, if the skateboard's moving downhill pretty quick and then all of a sudden you have a turn, you're going to know it.
I don't know if the robot toilet can kill you.
Well,
I hope
It can cause damage.
certainly becomes just
like
So-
two.
If you were to continually flush that toilet over and over and over again, you could potentially clog the pipe up eventually and cause that to overflow and damage someone's property.
I was just imagining someone being murdered by a pop-out.
No, I don't think anyone's going to be murdered by it, but
I don't know, middle of the night, walking into the bathroom without the light on,
Slip on
slip
the
on the
floor.
water on the floor, and whack your head on the tub, you're dead.
So there's all kinds of vectors there to look at. All right.
And then
So
when
now
you're in the
we
hospital getting morphine, you hack your pump, your morphine pump and kill you. So
That's going to be
Well-
a CSI Cyber episode. Just you wait.
that's all you need to say about that show.
Those pumps are full of vulnerabilities as well.
Yeah.
So RF hacking. All right. So I got some demos we're going to do here, and then we're going to get into the illegal stuff here in just a minute.
Yeah.
So monitoring. This is where most people start off. There's lots of activity for you to go out and actually listen to for fun. Voice communications, broadcasts, very popular to go out there and listen to. Digital modes. One of the things that I did as a kid was monitor POCSAG. Does anybody know what POCSAG is? Elvin.
Old school pager.
Old school pagers. So there was one of these systems running VHF on top of Sweat Mountain, which as a kid I still lived over close to that. I took that hardware terminal node controller, had a ham radio, I had the TNC hooked up to a TRS-80 Model 100 laptop. Ran through, I wrote a program in the basic interpreter in there that just read off the serial port and waited for data, and when it got to carriage return, it would then actually print that onto a thermal printer and would sit there and just print out pager messages all day long.
And people think those communications are private.
Yeah.
So they say things they shouldn't say in
Can
public.
you
Yeah.
say things on a pager?
Yes,
Alphanumeric
yes.
paging.
It's a text message.
Yeah.
It was the original text message.
Yeah.
I'm remembering those. I'm thinking of beepers, I guess.
No, no,
Yeah,
you're thinking
we're
of
talking about the same thing.
Yeah.
But so the protocol is used for paging systems, but there are such things as alphanumeric pagers. So it's think of SMS.
it's like SMS crossed with Twitter.
It was 7-bit ASCII encoding.
Yeah.
So that's like what doctors use, right? So I don't know if
They are still used a lot in hospitals. So they have a lossy coax that they run through the ceiling, and they carry it around their pagers, and essentially this coax turns into a giant antenna system around the whole building. Many hobbyists will specialize in certain aspects of monitoring. We're going to talk about a few of those more here in a little bit. You've got to know your operating frequency and the mode of who you want to actually go through and listen to. If it's a digital mode, you got to know the protocol and the encoding scheme that you're going through and using.
And it's all
So-
well documented online.
It's all very well documented online. So if you want to determine your target's operating frequency, here's a number of ways that you can go through and do that. There are frequency guides that you can go through and purchase. Oh, I want to know what frequency the Woodstock Police Department uses. Well, all I got to do is open up my handy Atlanta frequency directory guide, and I can go through and figure that out. And I know their output frequency, their input frequency, and their PL tone that they go through and use. We can examine and research equipment. So if we go through and see somebody using a particular piece of equipment, well, go to Google, look up that piece of equipment, figure out what the operating capabilities of that equipment are, and you instantly know a lot more about that system. Measure the antennas. Remember how we talked about that a lot of the function of an antenna's frequency is dependent on its length. If you go through and you're looking at particular antennas, you can eventually get good enough to just eyeball it and say, okay, this is VHF system, this is UHF system, this is a 900 megahertz system. Check the FCC database for a license. The federal government will help you out greatly here with this one. If they have actually got their own license, you can go through and figure out what frequencies they are approved to operate on. You can scan commonly used frequencies. So like there's all kinds of references you can go to and find lists of common like business frequencies. To go through and look those up, plug those in a scanner, go through and listen to that for some time period around your target. Chances are you may find something interesting there. You can get a frequency counter. We're going to demo that here in a second. We'll go through and tell you the frequency that a nearby strong RF source is operating on. And also you can try common offsets for a repeater pair. So if you know someone is using a repeater, typically you're going to shift in one direction or the other by a specified amount. And you can find additional frequencies by doing that. All right, so frequency counter. I already told you what it's used for. Many of these you could say leave this somewhere, let it run, and then store your frequencies that it has picked up, say overnight somewhere, go back to it, and then download the list off of that. So I just happen to have an antenna analyzer here that has a built-in frequency counter that is in here. So we're going to go through, we're set on the frequency counter section here. And I'm going to use some target RF device. So here we're set up, and here I'll let you look at this. So what we're going to do is I'm going to transmit here. Yep. It's going to read a frequency out here. So tell me, what does it say?
Nothing.
Let's turn it off.
146.534.
All right, K4BRG. All right, so now we know the operating frequency that I was using on this radio. So what does that say on the top line of the radio?
146.535.
Okay, so it's off by 1 kilohertz, but we know instantly the operating frequency of this particular radio here. So that is a real good way, is just to have physical proximate access near someone using an RF source, and you can go through and figure out what frequency they're actually operating off of. The next thing that you can do is use a tone scanner to go through and figure out what subaudible carriers are being used. So this we can go through and look at PL tone, CTCSS, or DCS using this particular method. If the radio has automatic sequential scanning built into it, it's a very quick way to do that, and you can defeat these systems in a matter of seconds. A manual method, you could go through and literally try each individual subaudible frequency on your device one at a time until you find the right one. It still functions that way, it's just slow to go through and do that. And once you have that information, it allows you to configure your radio identical to your targets. Some ham repeaters do not publish the tones, and they're marked as closed systems, but they're easy to, again, go through and bypass and figure out. So we know we have just determined through our frequency counter the operating frequency of this radio without actually looking at the radio itself. So I now have this radio set to the same frequency. And I want to know, I'm going to guess that there's a tone that's being used on this particular radio. And if I don't know what it is, I've got a real quick way that I can go through and find that out. So I'm going to go through here, turn the tone system on this radio, and then it's got a scan feature. So I can go through and demo this and see how it's going through and scanning through the different tones there. All right, so if I transmit with this radio, there, it found it.
173.8.
All right, so it found it just like that. So now, it's kept scanning, do that to it. Now that I have that information, and I know that the tone that this radio system's using, all right, now I can go through, and I have that now saved in this radio. Watch what happens. Oops, sorry, that wasn't supposed to happen.
K4BRG.
I'm now getting into that radio system here, and what did that take me 30 seconds to do? So, secure, yeah. So, you see on the front of that package, when you buy a set of FRS radios for your family, you see on the front of that package, 4,000 security codes. there's your 4,000 security codes defeated in 30 seconds.
Now, for those radios, you can typically say like, no privacy tone point. Though, if you're in a radio in that mode, you also get to listen to all these other ones, but it'll have like the carrier in it.
Yeah. So if you do not have a carrier turned on your radio and you just want to listen to somebody who does have a carrier, there's nothing more you need to know than the operating frequency. Again, remember that the whole point of those switch bypass systems is to avoid interference on their end, not on your end. It has nothing to do with you, unless you want to transmit.
Which you've never.
Which you should not do.
Yeah, no, it's
All right.
Never.
All right, radio modification here. Really easy to do. If you're comfortable working with the soldering and desoldering, you can usually do these modifications here in just a matter of about 10 to 15 minutes. Taking the radio apart, looking for a particular diode, resistor, jumper, literally the old school jumpers that are on the header pins, moving those over usually will require you to go through and say reset the radio. Some of them will let you do it through like a hidden hardware menu too. Those are kind of rare. Some of them you can do it through like third-party firmware upgrades on some of these radios. So what they've done is they built this real capable radio system, but then they put a governor on it to limit the operation down to that. So normally when you go through and do these, so typically these will be done on like ham radio equipment, you're going to get extended receive and or transmit modification. So a quick Google search for this particular radio down here, the ICOM 746 Pro. I go through, find, here's the, and there were other diagrams in here to show you where this location is on the DC board, but it goes through and says you, for TX expanding, remove these particular resistors in here, and points out to you on the PC board exactly which one they are. So this is surface mount work. It's a little difficult to do, but if you've got enough patience and skills and a steady hand, you can go through and modify this radio. Once you've gone through and modified this radio, this is an all-band 100-watt radio, you can now receive and transmit from 100 kilohertz to 60 megahertz, no gaps, as well as from 118 megahertz to 174 megahertz. So there's quite a number of services that fall in between there. Basically, your entire NF and HF band falls into there. And then a lot of VHF applications. Your aircraft band is included in that. A lot of business applications are included in that band right there. Just by removing two resistors there. Pretty easy stuff.
I'm guessing that voids your warranty on it. How much expensive?
Yeah, it would void the warranty. In most cases, there are legitimate purposes for doing this, for say like Mars and Civil Air Patrol modifications. Usually though, they will want you to either have the manufacturer doing that, or more commonly, the vendor that you purchase it from, they go through and do it for $30, $40.
And how much does that cost?
I bought this one used for about $900, but the brand new is $1,800.
Feel for the risk.
Yeah. Existing equipment that you can go out and find. Remember, this stuff is very slow to change, and sometimes when somebody does go and change their system out, they dump all of their gear, and it is all of a sudden widely available. So these radios that may have been Motorola, say Motorola is famous for this, they come out with a system, and these radios are a couple $1,000s a piece. Well, then when somebody dumps their system and goes on to something newer, now all of a sudden these radios are a couple $100 a piece. They require proprietary software, which I don't know where to get that from, but you need a rib cable to go through, and then you can go through and reprogram these radios, for example, for your own purposes. Picking up radios that are already configured for wide operation. These are extremely famous right here, these Balphone radios that you can pick up on Amazon all day long for next to nothing, and we're going to talk about these a little bit more later. Picking up used equipment from eBay, or purchasing amplifiers as well. There's some attacks you can do with amplifiers by desensitizing signals, and basically the concept is you're just using such a strong signal, even though you may not be on the same frequency as someone's actually operating frequencies, you can desensitize the radios and bleed through into the radio system. All right, so looking at actual incidents and the unusual. Logo does a lot, doesn't it? All right. So this is where a lot of the more interesting stuff comes into play. All right. Anybody familiar with the thing? Does anybody know what this is? You know that? Recognize that stuff? All right. So this was placed inside of a gift. We'll call it a Trojan horse, if you will. Operated for 7 years in the U.S. Embassy in Moscow. And it's a passive transmitter that has a microphone built into it. And this is sometimes referred to as an RF retroreflector. And what it requires is external power from an RF source to actually get this thing to operate. So basically, you would have to use, say, like a directional antenna. You would actually have to apply power to that, pointed in the location of this to get it to actually operate, and then it is going to retransmit your ambient audio from the room, so it could then be nearby with the receiver picking that up. So this was placed in the Great Seal. So this is a photograph from the NSA Museum showing it hidden behind there. The Great Seal is actually carved on the other side, but it was a gift from the Soviets to the U.S. Embassy in 1945. And they discovered in use, they discovered this while it was in use in 1952. So this actually did get used at least one time. That can be proven. Similar to how RFID devices work, that's a whole other huge giant talk that I really don't cover here, but they work in a very similar manner. They require an external power source to work. All right, number station. Run by nation states. They typically will operate on HF. You're going to see them transmitting sequences of numbers and sounds usually. There are exceptions to that. Most of them are recorded or computer-generated speech. There are a couple examples of them actually running live. There is no definitive source that can say that they know the purpose of them all. There's a lot of speculation that they're used for communicating with spies. And there's a lot of evidence to back that up. I don't know what they're used for, but you don't go out and run a very expensive operation like that for 20, 30, 40 years on a schedule, running the same type of content every time without somebody coming and finding you, unless it is some type of a nation state running that. So I can say with a lot of confidence that these are run by nation states. The actual purpose, I really don't know. We're talking with the SETI project. So a real famous one, the Lincolnshire Poacher, is a real famous one that ran on about 16 different frequencies, had a daily schedule, ran for about 45 minutes a day. They did, I think, 5 sets of 200 blocks of numbers. Usually they come in a 5-digit string, and usually are read by a voice. I've got some. We're going to listen to one here for just a minute. But if you want more information on that, there's it's called the Conet Project. They went through and recorded several hundred of these, and they've got them on CDs that you can go and actually listen to these. But the first CD is up on YouTube. And we can go through and I'm just going to play this for about 30 seconds and just listen to a couple of these. Here's the Lincolnshire Poacher. And then after this, it goes into reading the numbers. 6, 4, 7, 5. 6, 4. So some of those have been in operation for literally decades. And they all about sound the same, but if you go to the Conet Project and listen to those, you can hear hundreds of them. All right, another real famous one. This is still considered a number station, but it's UVB-76. It's known as the Buzzer. It was operating out of the Soviet Union. This is actually still operating today. The original location was about 25 miles outside of Moscow. It was found. This is an actual photograph. After it moved in September of 2010, somebody went to the location, looked for it, and actually found a logbook in there, which helped bring some insight as to what it was actually used for. This one was very unusual in that it would literally just do this, make this buzzing noise for years at a time, And then every couple of years, somebody would get on there and make an announcement. Now, this one was thought to just have an open microphone in a room with a buzzer sitting next to it, because occasionally you would hear like conversation way off in the background or footsteps in the background, rather than this just being directly fed by some oscillator making the buzzing noise.
What could that possibly be?
So the theory based upon the content found in the logs was that it was for military purposes. A lot of people.
What purposes of buzzer?
Well, hang on. Good question. The buzzer itself, nobody really thinks is that special or significant, but it had the theory behind it was they wanted to have a system up and running that somebody could be listening to all the time in case they needed to use it, and by having it actually operating, you knew that it was working. That's a very expensive way to just get high availability there, but that's what.
So by hearing a buzzer, you know that it's working.
You know that the system is working, but if you're listening to it, waiting for a particular message, yeah, you know that the system is up and running, and you already basically have your infrastructure up and running in case you need to use it. It's the best
Like launch the missiles now.
Yeah, exactly.
Yeah.
You said that they found a logbook.
So the contents of the logbook, I haven't seen like pictures of it or scans or anything, but the context that goes along with it is that was by looking at the contents of the logbook, it was determined to have military purposes.
Another cool thing with SDRs is people put them online on a web interface, and there are multiple SDRs online, scattered all over Russia that you can go through with your web browser and listen to local broadcasts, including this one.
Yeah. So I've got another link here.
Which you couldn't receive from here.
But it's still buzzing now.
It still operates.
Yeah, it's still operating.
It moved to 2010. And here's one of the voice messages.
Yeah, that's a great message.
All right, here we go.
So we go to unbox it.
So again, this occurs every couple of years that somebody actually says something on here. So they go through this message, and then it goes quiet for several more years.
Wow. What does that mean? In Russian, right? I mean, what are they
Yeah,
saying?
well, so he's spelling it out. They're identifying UVB 76, number sequences, and then names. I mean, that's literally what he's saying, but I don't know what that means.
You gotta be a spy.
You gotta have the decoder ring. Then it
That's
makes
right.
sense.
That's right. All right.
This is just to drive the NSA nuts, first.
Yeah. All right. Pirate radio. This could be a whole week-long presentation just on pirate radio. But the way that we look at it is, it's an unlicensed use of radio itself. There are certain bands that do not require licensing. That is not what pirate radio is including here. Typically, we're talking about either AM, FM, or some type of shortwave broadcast. Can include two-way transmission. So if you're talking about, say, somebody using ham bands without being licensed, that would be a form of pirate radio, although that's not typically the first thing people think of. It goes way back to the start of radio. There's a variety of content types. It may be a talk show. It may be music. It may be whatever. Somebody playing Kenny G 24/7, whatever they so desire. Variety of delivery modes, but again, typically it's going to be something up here. The FCC will go after it if there's interference. Easily accessible equipment. You can go on eBay and buy your own FM transmitters. You can buy surplus real FM gear that came from, say, decommissioned FM station and go and purchase that stuff. So you run like a 100, 150 watt, 250 watt transmitter. You can pick that up for about $1,000. The legitimacy of pirate radio is relative, and a good example of that is propaganda. So if somebody, like say a nation state is actually running a particular message, and it is legal for them to transmit that in their country, but the intent for it is to be received somewhere else as propaganda. That is another way to consider something being pirate radio. All right, Acoustic Kitty. So this is real. It was a CIA project that ran during the 1960s, cost $20 million. The intent was to spy on the Kremlin and Soviet embassies. And what they did was they took a cat and they put a transmitter in its chest. They ran a microphone to its ear and then ran an antenna down its back and tail. All right. The first mission failed due to a denial of service attack via a taxi. The cat got run over by a taxi outside of the the whole conclusion, and this is published as a 2-page document that you can go through and find. There's a lot of redacted content on it, but basically the bottom line of this whole project, $20 million. Cats are difficult to train.
By the way, there is an article about this project on Wikipedia.
Yes, there is.
Why didn't they use dogs?
Well, we're going to talk about that in a little bit. Actually, that's why I got this right here. All right, the Duga 3, the Russian woodpecker, as it's sometimes known. So this is called the curtain array antenna here, and this actually sits right outside of Chernobyl in Ukraine. It's in over-the-horizon radar system. This was the third variant of this, hence the 3 on the suffix there. And they were using it for early missile warning systems, was the whole point of this whole Duga project.
It's the equivalent of our DO line.
Yeah. Ran from 1976 through 1989. Now here, this is where it caused a lot of problems here. This is 10 megawatts effective radiated power. So they're getting a lot of gain from this curtain antenna array here. Well, you saw the picture of me over in Russia at 10,000 watts. This is 1,000 times greater than that right there. So this could literally be heard all over the world. Now the problem with this is we look at stuff like pirate radio, we look at stuff like number stations. Those are typically going to stay on the same frequency. This did not do that. This operated all over the HF band, so they would change the frequency all the time when they operated this. So it caused all kinds of interference with legitimate communications.
Why would they change the frequency of it?
Maybe they thought it performed better on a particular day. I really don't know.
So if they changed the frequency so that they're using it to detect like missiles and bombs being sent out?
Missiles, yeah, was the whole intent of it.
So
It was
you
an
do
early
something like
warning
this, it's basically scanning out there all the time, and
It's like it's radar.
is coming through.
Yeah.
They can know.
So it has a 10 hertz. We'll play it here in a little bit, but it's got a kind of a 10 hertz ping to it, and in between pings, they're listening for a reply off of a metallic object. Is the way that actually works. Very wide bandwidth. It was like 40 kilohertz wide, and if you know about the HF band, 40 kilohertz wide. Those are entire sub-bands of HF, depending on who the user is on that. Disrupted legitimate communications, and there were some American hams that actually attempted to jam it. So they would create their own 10 hertz synchronized signal with it to try and actually blank it out. One thing that happened during this time frame is television manufacturers were actually having to basically put in anti-woodpecker circuits in there to go through and ignore this signal if it was actually received on television. So we'll go through and listen to just a couple seconds of it here of an actual recording of Duga 3. You can hear that real fast pace. It's in between those tones, it's looking for a response.
So I mean, there's probably not good information on this, but were they like actually generating some visualization of that? Do you think?
You would have to, yeah.
Yeah.
I mean, that's the only way I can think of that this would actually be effective for you. Would be you can use. So there's a concept you can use TDR, time domain reflectometer. Yes, where you can go through and say find faults in systems. And the same concept works in radar systems, where you're measuring that time between when you stop transmitting and then when you receive, and then you're looking at the differences between those time intervals to determine, all right, is something moving towards you, away from you, how fast it's moving, things like that. All right, Van Eck freaking. So this is pretty interesting right here. So the way that this all started was looking at ways to go through and monitor unintended emissions from different systems in order to try and recreate that original signal. Now, where this actually started first, the first they proved the concept, was in CRT tube devices. So you have a beam that fires actually out the phosphorus screen that draws your picture out on there. Well, there's a lot of similarities between that beam and, say, a television signal. You have a refresh rate, things like that. So they were able to determine that it was possible to basically recreate your original screen image by monitoring for that as if it was very similar to a television image that was being transmitted. It is possible to reproduce in other devices. It's extremely difficult, though. There's not a whole lot of research available about it. In 2004, there were some researchers that showed that it was possible to actually do this in LCD monitors. I don't know if anyone's actually done an actual proof of concept. One thing that came out of Van Eck freaking was a term known as Tempest, which was a government standard for basically shielding equipment. So if you had equipment that you were using for sensitive purposes, your monitor may have to be a Tempest compliant monitor, meaning that it was shielded to prevent this from being recreated remotely. Some similar work has been done. We were talking about the Thing earlier, as that was with using intentional emissions. Again, Van Eck freaking is unintentional emissions. But Michael Ossman did this. I saw him do this at DEF CON 22 as part of the NSA play set on RF retroreflectors. And that one's a really good talk where he actually goes through and used a MOSFET that he put in line with a keyboard and used two hack RFs, one to transmit, one to receive. And he was going through and was actually able to record keystrokes over RF from an implanted MOSFET inside of the keyboard cable. And so a lot of this came off as after the NSA Tau Ant catalog was published. So it's got all kinds of crazy names. I forgot the names that he was using for his different projects. But he was trying to recreate VGA signals, USB signals, things like that.
You're talking about the TAO that Taylor
Yep. So it was kind of making fun of the names. So it's got some crazy ass name that they were using for these individual projects. All right, Captain Midnight. So this was a real early case here of a hijacking scenario where January of '86, HBO went through and started scrambling their satellite signals. So satellite users were then either going to have to pay a monthly subscription or purchase a descrambling device in order to actually receive HBO television. So there was a Florida man, John McDougall. He was actually working at a company that was doing satellite uplinks. He had the knowledge and equipment to be able to do this. He was eventually caught for this. But he was protesting HBO doing this. In April of '86, he hijacked the Galaxy 1 satellite, which was the satellite that was carrying HBO. He hijacked it for 4.5 minutes and transmitted this message.
I gotta admit, I kind of wish I was older, so like I could have been alive back when stuff sucked so bad that you could actually hijack a satellite.
Yeah.
That just sounds awesome.
Wait a minute, you seem to think that you can't do it now.
Yeah.
It was a lot easier back
How old do you think those satellites are up in space?
Yeah,
They're the same satellites.
Once they put them up there, they still go. And the interesting thing about satellites is there are documented cases of satellites being put up, they stop functioning for decades, and then all of a sudden they turn back on their own. The Max Headroom incident. This is one of the most famous hijacking incidents that ever took place. So a little bit later, so the first one was April of '86, this one's November of '87. It took place in Chicago, Illinois, 2 TV stations. WGN TV, everyone's probably heard of them, and then another one, WTTW. WGN, this
Aren't
guy.
they public broadcast?
No, WGN is the superstation in Chicago. I'm trying to remember, I know what you're talking about, and I can't remember the call sign. But WGN, he hijacked them for about 15 seconds in the middle of a news broadcast. WTTW, it ran for about 2 minutes. He hijacked the TV transmitter uplinks here. WGN had a failover here. They had a second uplink, so when they noticed something was up after 15 seconds, they were able to fail over to that without continuing to disrupt their transmission. WTTW had no failover protections, but this guy stopped after about 2 minutes, and this occurred in the middle of a Doctor Who showing after the news. Still remains unsolved, and I'm going to show you guys a little bit of it. The end of it is kind of, you'll have to watch it. But
there's a staggering amount of analysis people have done on this.
Yeah, I'm not going to play it through the end, but we'll watch about a minute of it here. So it's kind of interesting.
So
You'll see it start off.
Why is it unsolved? I mean,
They never figured out who did it.
so it's just some guy was, you know, he was able to bug out before anyone found him.
He only operated for about 2 minutes. So here's Doctor Who.
Love it. Oh man, that was awesome.
By the way, they think that funny looking pattern in the background is corrugated steel, but somebody's waiting.
That was awesome.
All right, I'll stop it here, but there's more interesting content if you want to watch it on your phone after this.
How did they catch John?
That I don't know, but there were some people that had observed him moving ground satellite dishes to point at Galaxy 1 for like a minute and then go back into its original position. People who were working with him saw him doing some suspicious activity, and then like right after he was doing these suspicious things, that occurred. So I would imagine that had something to do with it, but I don't know the full story.
His OPSEC wasn't.
Yeah, that's real bad.
Well, yeah, I mean, he was practicing this in front of others. This is effectively what he was doing. All right, news helicopter report hijacking. So whenever you hear the the news chopper talking about how bad the downtown connector is. So there have been a number of incidents of this happening where somebody is waiting, listening for that link from the helicopter to the studio to insert that audio into their transmission, where then somebody jumps on top of that and swears or plays music or whatever. So eventually the fix for this was they started recording those broadcasts in advance, so it's not actually live when you hear those up and running.
WSB, I've been noticing some of the traffic reports are interactive talk show hosts now. So
Most of the time, it's someone actually in the studio with a chopper sound behind.
really?
So
Not surprising.
there may be some exceptions to this, but there's an exception to pretty much anything we're ever going to talk about here. But for the most part, they're all recorded in advance. I mean, they may be recorded 5 minutes in advance to make sure it's pertinent information, but they stopped doing that.
Or they have someone they're relaying through.
That could very well be possible too. One interesting phenomenon that happened when these things would occur was a lot of the blame for those was placed on monitoring information sources. So there's a man named Bob Grove who lives in North Carolina. He ran a magazine for a number of years called Monitoring Times, and he used to publish all kinds of information about monitoring sources. So this information may have been available from, say, his magazine. There were other sources for it as well, but people started actually blaming him after some of this stuff actually occurred because he was providing the details on how to, what the frequency was.
How far back is full disclosure?
Well,
security through obscurity is the problem. That's what they rely on.
So I mean, it's I demonstrated here in 30 seconds how to bypass a radio system. It's not difficult to do at all. All right, fast food drive-throughs. There's a lot of videos on YouTube about this one right here. So the drive-through operator is using a wireless headset. All right. Well, it's using a pair of split frequencies between the headset and the speaker that's out at the curb in the drive-through. So most of these operate top-end HF bands. VHF and UHF are very popular. They're using very low power. So if you were to go through and say they're using half a watt, and you were to go through and say use 100 watts, there's going to be a slight discrepancy there that then you could inject yourself into the conversation. We talked about you running an amplifier and desensitizing radios. That's another vector that this can be done with. So even if you're not on the right frequency, but you're running, say, a couple hundred watts through an amplifier or something like that, because you are so close, those radios can be desensitized, and you can inject yourself through the radio system that way, even though you're off frequency. This can disrupt business severely. There's one video that I saw on YouTube. These guys were doing this, and the fast food place actually had to send someone out to the curb to take orders because they were disrupting so many orders by doing this.
How powerful do you have to be in regards to like the actual transmission to cloud or someone's transmission?
Depends on how far away you are from them, but it's not that difficult. So we're going to talk about NOAA weather radio here in a second, and I can give you some examples.
For the Max Headroom one, you had to really be pumping it, right?
No, he hijacked the uplink.
Yeah. So what you're doing with that is whenever you have like a TV or radio station, they're going to be somewhere not necessarily right next to their actual transmitter section. So they're going to have an uplink that's going to feed point-to-point link directly to their repeater. So exactly, and then you've got 100,000, 50,000, 100,000 watt radio at the other end. So if you can man in the middle of that. Which doesn't take a lot of power because they may only be running 5 to 10 watts on that uplink thing. And so if you can get an amplifier and overpower that, it's gone. All right, baby monitors. So these really aren't around too much anymore in the fashion that they used to be in, say, the late 80s, early 90s. But these were 49 megahertz devices, very easy to monitor. Basically, any scanner or receiver you had would be able to listen to these. They can be hijacked by other 49 megahertz devices, walkie-talkies, wireless headsets, other baby monitors. Usually these had just a couple of channels to select from on here, maybe 4 or 5. Real good information disclosure because people just leave these running 24/7 inside their house, and you can hear every conversation that's going on within proximity of the nursery. Some people have been known to inject non-baby noises into the baby monitor. So the actual transmitter is running next to the crib. They've got a monitor in the living room or say in the bedroom, and then all of a sudden, I am the devil comes across the radio and it's a little disturbing to people.
This is what you use to spy on people's houses before Samsung televisions.
Yes.
Yes.
Yeah. All right. Your old cordless phones operated on the same frequencies. They had 25 different channels.
I have one of those.
Well, rarely used except in Keith's house.
I don't use it anymore.
Oh, you're using it more.
Sure.
Well, you may remember there was a channel button on those to be able to cycle through those 25 different channels, because sometimes you would pick up the phone and you would be able to hear someone's conversation without even trying. You'd hit the channel button, you'd select a new channel between the base and the handset and move to another channel until you found one that was clear.
This actually,
man. Back in my old dorm room in Southern Poly, this is around the year 2000. I remember, I think I got a new cordless phone. It was one of these, I think it was one of these new 2.4 gigahertz phones. Or new.
Probably 900 megs back then.
Yeah, whatever it was. But I remember actually, the base of the phone was in our dorm room. I took the phone with me in my car one time and started driving down the road.
Yeah.
And I swear to God, that cordless phone worked all damn near the highway, the 75.
Yeah.
And blew me away how far
You could go before it dropped off.
Yeah, amazing.
Yep.
I mean,
I had an instance where a guy, I was doing consulting and a guy called me and asked me about printers, and he was asking me all this technical stuff, and I explained all this technical stuff to him over the phone. And then I went over to my neighbor's house, and they said, "Hey, we've been thinking of getting a printer now. And they started asking me all these very, very technical questions. And I'm like, wow, I just had this conversation. This is so weird. And then they messed up and they heard I was using that phone, and they overheard the entire conversation.
So looking at kind of the same vectors and impacts as the baby monitors here. Cell phones. So some of your original flip type cell phones here were operating top end to 800 megahertz here. They were used to be very easily monitored. Once they established a connection, they would not change frequency. So as long as that conversation was and you found that lasted, and you found that conversation, you were able to listen to the entirety of the conversation. 800 megahertz used to be easily monitored. Your old scanners would cover those bands. So, for example, like this scanner right here, you could change the firmware on it and would cover the 800 megahertz band completely. This eventually led to a lot of scanners being locked about in the mid-90s. And back in those days, lots of interesting conversations. We got through, you know, late 80s, early 90s, how expensive a cell phone was. So was listening to one time and was hearing people discussing how to move a little over $2 million between about 10 different bank accounts that they had open. So there was a real interesting one. So GSM is really built with kind of encryption into it from the ground up. But there was another NSA playset talk at DEF CON 22 on GSM where they're actually able, now hard drives are large enough, you can generate a rainbow table for all the possible combinations for GSM keys. And you can go through and actually start to decrypt a lot of GSM traffic.
It's 851, right? 852. 853.
Oh, yes. All right, trunking radio auto patches. So this was real interesting. So you used to have you still have these conventional radio systems that are operated on VHF, UHF. Well, I think Kings Bay Submarine Base in about 1978 or so was the first place to use trunking radio. And so what trunking radio was originally designed to do was to take a bunch of disparate users and put them on the same radio system. So rather than saying you're running a county government, rather than having 20 different frequencies to operate off of, maybe let's go down to like 4 or 5 frequencies that we're going to operate off of, but we're going to jump in between those frequencies and share them. So if we have one frequency for the dog catcher, and they use it for 5 minutes total in one day, they really don't need their own frequency. We can work them in to these 5 we're going to rotate through. Well, originally, people thought that, yeah, there was a lot of security in that, and in a lot of your old, these don't really exist so much anymore because of cell phones, but you had auto patches and radio systems, which was a way to marry the POP system to a radio system. So you could key up the radio, use CTMF tones to make phone calls over the radio. So a lot of these, like police departments or counties, would put in a radio system, and on their police departments, they would get on the radio, key up the auto patch, thinking that they could not be heard. It was more difficult to hear them, but you could still hear them. And they would make all kinds of interesting telephone calls over the radio audio patch system, such as calling their girlfriends and then their wives finding out, or making drug deals over the police radio system. Practice usually ended very quickly after the first person got popped for this. Elkhart County, Indiana jammer. So this was real interesting to me because these people went through a lot of trouble to try and systems here. So this was first reported in August 1997 in Elkhart County, Indiana. They found multiple jamming devices placed inside of beach balls that were floating down the Elkhart River. They later found a jammer inside of a television. Somebody had bought a TV from Walmart, placed the jammer inside of it, returned the television, and then a couple purchased the television, plugged it in, not knowing that their TV was a jammer now. They had another device that was placed out in the sticks that had a seismic detector, so whenever somebody got close to it, it would stop a transmit. Couple responsible, their motive, they hated ham radio. This seems like an awful lot of effort to go through just to screw with ham radio. Yeah.
How did they find that?
That I don't know. I don't know the backstory on how they found
Bad
it.
upset.
Probably bad upset. But yeah,
Did
Google
Hannah
it.
beat them as children?
I don't know. I don't know why they hated ham radio, but they did. So we've already talked a good bit about this. Nothing really new here, but these are sold all over the place. A lot of people go through and use these when they read the packaging and say, oh, it's got security code. Well, I have all kinds of interesting conversations on it. Yes, sir.
Yeah. Why would you buy those? I was just asking this guy about his radio. He says it's $40 on Amazon and it works 8 miles. Yeah, why would you? That's probably more than that set of radios.
Okay, so he's got a Baofeng radio. Those are, to legally use those for those purposes, you need a license.
Technically,
these are
technically for the higher channels on the like tube backs you can buy at Walmart, you do need a license.
yes, those are
but no one ever-
GMRS. Yeah, right. So you have FRS, which is unlicensed. GMRS does require a license, and he is correct that people just buy them and just use them. But they do technically require a license to use the GMRS portion, which is the upper channels. So in order for something to be legally used for a particular purpose, it has to go through type compliance with the FCC to basically be approved for that purpose. And these are really the only things that will pass the type compliance are these radios, because these are limited to like half a watt or so. I forget what the actual limit is.
1 watt.
1 watt. So similar to like ISM devices.
So what's the distance that those like?
Well, again, it depends
radios
on
can go?
with these crappy antennas on here. Yeah, it's going to tell you 30 miles. Well, sure, if one person's on the other side of the Grand Canyon and there's nothing in between you, you can see each other. Yeah, that's going to work just fine. But most of this has to do with the height of the antenna, the average height, the average terrain that's surrounding you. Do you have a bunch of buildings in between you, or are you talking across a cornfield? You know, it's going to be a lot of different performance depending on those pieces.
I did the suburbs test. I think fairly typical suburb area. Got about half a mile.
Which is reasonable. Half a mile to a mile would be very reasonable.
Yeah, they're great for inexpensive communication, real-time communication between moving cars.
Right.
I was gonna just say that, like if you're driving, if you're carpooling down to Florida or something,
Yeah.
you need to talk between cars. That's really the
And
only use case I can think
voice
of.
activated headsets you can
Yeah.
inform. They're really kind of
Yeah.
cool. By the way, if you ever get into reverse engineering hardware, like anything that requires an FCC certification, for type certification I was talking about, they have to, that's public record, they have to submit schematics, documentation, everything to the FCC. You can go look that up online and get schematics for all your equipment and everything. It's really,
It costs a lot of money to do.
yeah, very expensive to get type certification.
All right, National Weather Service, NOAA Weather Radio. Most of you might be familiar with this. Operates all over the U.S. VHF frequencies here in Atlanta. We can listen to them on 162.55 megahertz.
It was sunny, 94 degrees, wind calm, Lawrenceville. It was partly sunny, 91.
So that just runs around the clock like that.
That's a speech synthesizer.
Yes, it is. Yes, it is. They used to do those as live recordings. Somebody would actually read the text and record it, and then they about 2000 or so they actually went.
And the first ones are real hard to understand. They progressively got better.
Yeah,
They're
that's
pretty
true.
good now.
So that particular transmitter we're listening to now is on top of Stone Mountain and runs at about 500 watts. So if you were to say go up on top of Sweat Mountain and be running 50 watts, you would be very easily able to control the radios that were in the proximity of that particular area, even though you're not talking from, I don't know, what is it, 30 miles or so between Stone Mountain and Sweat Mountain, something like that.
Tell everyone there's a tornado coming.
We're getting to that. Yeah. So there's a couple of ways that these things work. You can either go turn it on and just listen to it, or you can set it to only be activated when there's some type of severe weather alert that's going on in your area. And they use a 1050 hertz tone to unsquelch those consumer radios. So if you were to play a 1050 hertz tone over that frequency, it would turn all those radios on. Now they have a little bit more advanced system where it's using packet radio here. It's called SAME, Specific Area Message Encoding, and it uses a 5-digit, it's called a FIPS code. First 2 digits are your state, so like Georgia is 13, and then the individual county is the 3-digit suffix that's on there. So you could buy one of these radios, program your FIPS code in here for Fulton County, Cobb County, wherever, and then if there was a particular alert for your area, then it would unsquelch the radio and you'd be able to hear the particular alert. So these are well-established protocols. So somebody literally could go through and either open up radios with a 1050 hertz tone using a tone generator, or could go through and send out, zombies are attacking Marietta, downtown Marietta.
Yeah, the emergency.
That was a new.
Yeah, that was like the emergency message.
Yep.
Is that one of the codes?
No. So the FIPS code is literally just to get down to a particular county level.
So
there isn't like a code encoded in there that says it's a tornado or a storm.
So an example, I have one of these radios and we have it set, we're up in the corner of DeKalb County, so we want to hear, we're near North Fulton, we're also near Gwinnett. So if there's an alert anywhere in those 3 counties, we want to know it because they could affect us because we're so close.
Yeah. I live literally, you walk out of my neighborhood, you cross the street, and you're in Cherokee County. So typically when I'm looking at weather, I'll look at Cherokee County weather rather than Cobb County weather for that exact same reason. All right, WWV. So this is what Keith brought up. So this runs out of Fort Collins, Colorado. They've got a handful of transmitters that runs out of there. And it is considered, it's run by NIST. It's considered to be a time and a frequency standard. So when you listen to their time information, you can be guaranteed that that is accurate. You can also use it to calibrate other radios because they're being used as a frequency standard. So if you were to say tune to 10 megahertz on an HF radio, and you were a little bit off, you could actually realign your radio using them as a frequency standard to make sure that you were spot on here. Now, they normally, when you listen to them, you're hearing voice time announcements, but there's a subcarrier using binary coded decimal at 100 hertz that has time information on there. They publish the shit out of that standard and show you exactly how they go through and do that. So here's kind of their time format per minute, how they go through and do that. But the actual encoding that they use is very well known. There's a lot of consumer devices that will go through and sync up their time with WWV. The watch that I'm wearing right now goes through and does that at either 2 or 3 o'clock every single morning. Goes through and syncs up with WWV. So it's got a 10 megahertz receiver inside of it. He's got one too.
So
Inside of
Anything that
watch.
says
Those are the
atomic clock.
So
Yeah.
it's basically the atomic clock into that, and then that into an actual clock.
But that's not the atomic clock. Just
Right.
transmitting
No,
by
but-
the atomic clock.
Yeah, any device you see advertised that says atomic clock.
That's what it's
using
referring
that.
to. Is this right here.
Although some now use GPS.
Yeah, you get time information over GPS.
What's the power of that station to reach us from Colorado?
Ranges from 2.5 kilowatts to 10 kilowatts.
There's also a transmitter in Hawaii.
Yeah, WWVH, and then there either used to be a third one. Yeah, it sounds familiar. I don't know if it still runs, but yeah, they use different gender voices, but they're on the same frequency. I think Hawaii's a woman, I think, so you can tell if you're on that frequency which one you're actually hearing between male and female voices. All right, SCADA and ICS system. So
Like it's gonna have scaling problems. But only 2 genders be possible.
The other one being code.
So SCADA and ICS systems. So you have remote terminal units out at particular SCADA or sites that are using SCADA implementations, and they do use RF serial links out there. I'll give you one guess as to whether or not these are encrypted.
No.
All right, very good guess. SCADA systems, they're full of vulnerabilities. One of the big problems with them is they use really old TCP/IP stacks built into it. So say running an Nmap scan against
Will
a
render them
SCADA system,
dead.
right, will kill it. So these are some common frequencies, VHF frequencies, that these SCADA RF links actually operate off of. There are others, but these ones are the most common right here. So yeah, that's real comforting there that these SCADA systems just a little bit of RF gets right into it. You've got a serial connection right into an RTU on premise at some site. All right, power meter reading. Somebody did a full project here that's up on GitHub to go through and use an SDR dongle. These operate at 900 megahertz to go through and be able to receive these things. I've never actually listened to these myself, but from what I understand, they're extremely chatty. So these are the ones that send your usage back to your power company. Well, one of the other things that they do is they act as repeaters to retransmit information from other meters. So if you can imagine you're trying to daisy chain information down to your power company, and apparently they have transceivers that are located regionally to be able to receive these signals. But if you have a system that's far enough away that it can't actually reach this transceiver, it's going to go through and relay those messages through there. So these are extremely chatty.
Get the tinfoil out?
I'm sorry?
Get the tinfoil out?
Well, they would eventually come out and just fix the meter if they hadn't heard from it in a while.
Can you lie?
Pretty much, well, remember when we were going through and doing like the CVSS scoring on this stuff?
Yeah.
You can spoof just about anything.
You
The
just
problem
read
is
the
with the frequency that these things may report in, I don't know what that is. That may be extremely difficult to try and do, but if you were to say, be able to know that every 90 minutes it reported in, and you were able to DOS the signal exactly on that 90-minute mark, and then 3 seconds later you were able to transmit your own packet there saying you were using 1 kilowatt hour. Yeah. I don't see why you couldn't do that.
So when the head of the power company suddenly gets charged for 5 megawatts of use in one day because somebody's sending fake packets for his meter, maybe they'll put some security on it.
Could be.
Probably. They'll just credit his account.
Yeah, they'll just fix the issue as not a security issue, but a billing issue.
They'll blame him for telling us about it.
That's right. Remember, I told you not to do any of this stuff.
Right, it's the monitoring thing that, it's still your fault.
All right, tire pressure monitoring system, TPMS. So I think any car after 2012 or so has this in it. There's an actual photograph one, so you can see the valve stem and cap here. There's a little unit in there that actually transmits the tire pressure to your car's ECU. Computer that basically makes all the decisions in your car.
And there's aftermarket versions of those for people to put in cars that don't have.
I didn't know that.
Yeah.
These operate at either 315 or 433 megahertz here, so relatively easy access to get to these. Some cars, their ECUs have logic included in them that the car will not start or the engine may shut off if it detects an unsafe tire pressure.
That possibly and that.
No?
Yeah, exactly.
All right, ADSB. All right, so anybody familiar with ADSB? All right, one person. All right. So ADSB is a way for aircraft to actively report their positions instead of using things like transponders, which provide an altitude, or radar, conventional ground radar systems. There's a major problem with this system. There is zero authentication built into this. When somebody transmits an ADSB packet, you are who you say you are. You can make aircraft appear in the middle of the sky. Anybody see an issue with this?
Yeah, these planes will start diverting courses automatically based on proximity.
So there are 2 different frequencies that these operate on. Commercial aircraft, a little over 1 gig. General aviation, a little under 1 gig. Now, these systems are still expensive to go out and purchase. It may cost you $10,000 to outfit a commercial aircraft with ADSB, but I think by 2020 they all have to have it. So there's a site, Flight Radar 24. You can go through and look at live data on that, and they have a mobile application. So there's a screenshot I got off my iPhone there, and you can see real-time flight information off of that. Well, you can also use a SDR to go through and receive this, and then go through and decode that. So Flight Radar 24, they actually have a campaign where they look for people who maybe live in an area that they don't have good coverage in. They will send you the equipment to set up at your house. You plug it into the internet, and then you do a live feed back to Flight Radar 24 here. Everything's sent in clear text, can be spoofed, or it can be jammed. One of the interesting attack vectors for this that I saw somebody discuss is not necessarily making an airplane appear in the sky, but what happens if you have an airplane, it's a legitimate airplane, at one spot, and then a few seconds later, you make another one appear directly next to it with the same call sign, the same tail number, and then it starts to divert course. How would they know which is the real one? Other than maybe comparing it to actual ground-based radar, I can't think of a way that you would be able to do that. Somebody actually went through and did a proof of concept. Now they transmitted this into a dummy load, so this never actually went out over the air. This is about 2 minutes long, but it was very, very worth the watch.
I was here. I was there.
Where you saw him do that?
Yeah, it was the plane with your mom.
Yes, yeah, that's exactly right. So I've got a link in here to that Render Man's Hawk from DEFCON 20, where he went through and did that. But this is,
By the way, we're gonna publish the slides.
I got word while in the air en route to Poland that Nick Foster had actually implemented ADSB out through GNU Radio. You can see we actually have a valid packets, able to go out through GNU Radio. The honeymoon's over. Exploit number 1 is here. We have the potential now of putting data into the air. a radio plot for a MODES extended quarter packet. He also raised his game and impressed the hell out of me. He basically took ADSB in on flight gear, the open source flight simulator. Basically had one radio receiving real world ADSB packets, populate the virtual world of the flight simulator. It also has another radio that outputs from your little Cessna out to the real world. So, got a little video here. You can see on my right, Google Earth display, that is the output from the real ADSB receiver, the real world tracking. The virtual plane there, and at the bottom is the ADSB data stream out. Now this is done in very controlled conditions, basically dummy load, two radios connected to each other. It wasn't actually put out into the air. But, as you can see,
so this is
so
what
just
he's
to explain what's going on
translating
here, you see, okay, you've got
or
real
into a dummy.
planes there, VDR, 211 and everything. Those are the real flights. Your mom is not the real flight. Your mom may be as big as a 747, but that's not her. You see, it's got valid packets, valid information, and I'm not sure, I can't tell if it's showing up on the displays or not. Okay, so it is. You can see the flight path as he's turning around there over the bay. So we're generating packets that if you put this in front of air traffic control would show up on their display. Now, does anybody think that's a good idea?
That's a great idea.
What is he doing? Okay, is he about to buzz the tower? Really? Oh, it's going right for us! So if I was air traffic control right now,
You'd have a laundry
how fast would I
problem.
be running?
All right, so you get the gist of that.
So, fortunately,
That was funny.
I was gonna say, one of the best things about ADSB is you can tend not to just be other types of airplanes, but weather balloons, space shuttle, several other things. What a space shuttle.
Oh my God, yes. We don't space shuttle land at JFK.
You can actually bring the space shuttle back from the dead if you want to, or out of retirement, actually.
Wow.
During that talk, he actually showed like a smiley face over the city of airplanes.
So other systems to take into consideration here. Road signs, we've had discussions about that, of remotely controlled road signs, speed limit signs in particular. Drones, hijacking drones, there's been plenty of articles about that. Different locks that use RF, home automation systems, different security systems using RF. Like when Keith was asking about, cameras, wireless cameras. Well, nobody uses those. Weather sensors, porting fake weather data back. Cell and GPS jamming. There's an actual unit that's commercially available right there that'll jam cell signals, GPS, things like that.
Is that the one the guy was driving around in traffic with?
Yeah.
Jamming everybody out?
There's been several cases of that. There's been hotels that have gotten in trouble for doing that, jamming outside signals, so you have to purchase their Wi-Fi.
Yeah, the Marriott here in Atlanta got
RFID prox cards, that's a whole other world right there. Restaurant pagers, so when you go to a restaurant and they have a wait and they give you a pager. Well, those first started in about the late 90s, and I went down to Lenox Mall to go to a 2600 meeting. We have the 2600 meeting, and afterwards we go across the street to the Ruby Tuesday. I think it's still there. And they give us one of these, and this is the first time I'd ever seen one of these before. And we pop out a mini screwdriver kit, and we start taking this thing apart. We had this entire device apart, and of course, what happens?
It went off.
They page it, so it's sitting there vibrating nonstop, and screws are just rolling around. So we put this thing back together in record time, and then took it back in and gave it to the hostess there. But that was like the first time I ever saw one of those, and we just took it apart. Now, if you go and look at these things now, if you look at the backup, a lot of times they're going to have the frequencies that they're using on there. There's a guy from Edis Research, and I can't remember his name, but they make like the USRPs, which are the real high-end SDRs, where he went through and actually did that, where he was out with his company. He figured out there was, I think, 1 byte for the pager number and the checksum, and that was the only thing that varied between these packets that were being sent out to these things. So he goes out for work, and they're sitting at the table, and they got about 5 of these things there. And he's like, all right, read me off the numbers. So everyone's reading the numbers off to him, so he's punching them in. Then he sends out the packets and makes all 5 of them go off at the exact same time. So a little bit of mischief. Radio data system, or RDS. This is a subaudible carrier, or well, not subaudible, but it's a subcarrier that's attached to FM broadcast. So when if you have an RDS radio, it will go through and tell you who like the artist and the song is and things like that. So
You never actually have that information on it. It's always like the song title is
truncated.
Like the song title is the station name.
Yeah, I
and
see
then the like album is whatever bullshit they want to tell you.
Upgrade your firmware in your car then.
But also, I'm aware some GPS is receiving traffic reports that over RDS.
Yep. RDS has like a sister to it, and I can't remember the name of it. It's a 3-letter acronym. I can't remember the name of it. That's for traffic information. Robert? Yes.
What's the, I don't know if you covered it. Excuse me, if you covered it before. What's the emergency system on cell phones now that allows by location?
Amber alerts.
Yeah, where you weather alerts,
presidential alerts.
I'm not sure how those
I think
work.
that comes over SMS.
Yeah, that's a broadcast from the carrier.
It would have to be. I can't.
Pretty sure it
I'm
was
not
separate.
aware of another
Nobody's
system in place. You know, I don't know, but that is another vector.
Those are probably
It sounds like it's right for a zombie alert.
You have to do GSM, right?
Well, that would probably be over GSM. So SMS would go over GSM, or if it was data control channel or something that did it too, that's also over GSM. So it's a lot more complex over GSM, but I really don't know about
It's been too long since I've looked at that, and I've forgotten a lot, but I'm pretty sure it was a separate side channel thing.
Could be. The data channel is very underutilized, though I do know that in cellular networks. So
Sounds like a DEF CON.
yeah, I don't know anything about
right
it.
there.
I don't know anything about it. So proxy ham. So this came up. You were asking me about it the other day at work.
I got more info on it too.
Do you? Okay, all right. So this is basically about everything I could find on it just from some of the articles. But it was quoting about a 2.5 mile operating range with the frequencies that it's publishing. It's reasonable. They were trying to sell it at their cost, which was about $200. Well, I think when they say their cost, that's for that unit there. You're going to need some more equipment rather than just what they were able to provide. Basically, what you were doing is having a Raspberry Pi bridge 802.11 to 900 megahertz. So you would have this device somewhere within Wi-Fi range of an open hotspot or say a left hotspot, something like that. Have it connect over 802.11 to that hotspot, and then you would remotely connect to it, bridge through the Raspberry Pi over 900 megahertz. So it's got 2 antennas, so it's some type of MIMO setup here. But what they were trying to do was give you some type of anonymity by using this device. You weren't going to be really within Wi-Fi range of an open hotspot here, that you could be several miles away here and then use services like Tor on top of it. They were recommending a 900 megahertz Yagi antenna, so that would be basically attached to your computer through a 900 megahertz NIC, essentially. So you're doing Ethernet over RF. They were scheduled to do a talk at DC404, and then all of a sudden it got pulled. Then they're like, we're destroying all the units. That was on their Twitter feed. We're not doing this. There's not going to be any additional information about this ever. The problem with this type of device is this would work. There's nothing that would prevent this from actually functioning the way that they describe it. The cost might be a little bit off here, based on the additional hardware that you would need to actually purchase on the client end to get this to work. But all this is really going to do is slow somebody down from being able to find you. If somebody is out there actually trying to search for you over Wi-Fi, they're going to use similar methods to do it over 900 megahertz here. It broadens out the range a good bit, does make it a little bit more complex and time consuming to do, but this isn't really like some magic bullet to go through and all of a sudden disappear and still be able to operate over Wi-Fi. Now,
Well, you would think that they would have the answers, right? And they would show up based on the information they got from the ISP.
You're going to be natted behind. Are you talking externally or internally? If you're talking the ISP, you're going to be natted behind.
I'm assuming like I'm a criminal, right?
Yeah.
Okay. And so the FBI or someone is coming after me. And so they're going to know my IP address. Let's say.
Let's assume I got or the library or yeah.
Okay.
You're going to be natted behind whoever you're connected to.
Right. Of the Starbucks. Right.
Yeah. And then even if they show up where you are, you're still 2.5 miles away from that.
But my point is that I think they would actually show up at the Starbucks thinking,
yes, they would. They would start looking locally there.
Right.
Being like if the Starbucks kept logs, being able to look at DHCP logs and stuff like that to be able to actually figure out, what's going on.
Right. And if they found that,
compare proxy logs to DHCP logs, but they may eventually find this device.
Right. And then now they have a whole other problem. Now they got to go get somebody who can do triangulation of this 900 megahertz.
Yeah, but they're going to use the same process to find this box. They're going to be able to find this box here. The problem with that is that you don't know when someone has shown up to the Starbucks if you're 2.5 miles away, looking around for stuff. So
put a seismograph in.
That's right.
Or the wireless, the camera module for the Raspberry Pi. So when they show up,
when they pick it up,
you see a face looking at the box.
Put that on Facebook.
And you go down, you shut down, and you go down.
Yeah. All right. Well, there's an enhancement for it to do that, but you're making it more complex. You're buying yourself some more time, but the same methods that you're going to use to find that box are the same thing that they're going to use to find you 2.5 miles.
Well, maybe. I mean, like this now I'm doing radio, right? So before
you're always doing radio.
Well, yes, that's true. I was doing Wi-Fi, but I mean
Robert could find you.
Robert could find you, right? But I'm saying, like when the FBI showed up, they probably asked whatever ISP Starbucks was using. They said, "Oh, that's the Starbucks on Main."
Get a physical address for the IP.
Right, and then so they show up, and then I'm not there, so now they've got a whole nother.
Well, they're gonna. Well, so it's either going to be a device on the LAN, okay, that's behind their gateway, right? Or it's going to be their access point. What's the most likely of the two scenarios? So it's going to be the access point. If they're going to go through and be able to compare, proxy logs with DHCP requests. Here's a DHCP leak, matching this IP address. I seriously doubt Starbucks keeps proxy logs. To go through and say, well, here's an HTTP request matching this source IP. That matches your DHCP reservation.
Right.
For this, we're going to go look at like the OUI and determine, well, that's some plug and play, USB dongle for 802.11 adapter, and then be able to go through and find this device. Yes, there's a lot of work involved with that, but it's done every day.
Yeah.
Robert, speaking of, if you had to climb that 900 megahertz, what do you think you were getting paid to do it? How long do you think? Days, hours?
It could be done in an hour if you have the proper equipment. If you have the proper direction finding equipment, as an individual, you could probably track that down within an hour if you were determined enough to do it.
My point is they wouldn't have brought
faster.
Two could be faster, sure.
But isn't it more of a function of money? It's like you need the money to buy the gear to find it, rather than.
But if you're the FBI, you've already got the
It's
gear.
obvious that the government has the money.
Yeah, here's the thing.
But that's the barrier to entry. Is the money.
Here's the thing. Having done this for the government before, here's how it would work. They show up on site and they review the camera footage for the Starbucks or put somebody there to find out if it's somebody who's actually in the restaurant. Once they figure out it's not them, it's somebody outside the restaurant, then they're going to bring in a DF crew, and they're going to be able to DF all the equipment with them from DC to daylight. They're going to be at your house in a matter of hours after they find this guy.
If you don't know your box is busted to start with.
Well, yeah.
Yeah.
I think that's my problem. I'm envisioning them coming in guns drawn in the Starbucks.
Yeah.
No, they sent someone in like Keith who just walks in with.
So yes, if you did know that this box had then been compromised at Starbucks and you cease transmission, there's, yeah, you're fine.
Unless your OPSEC is terrible and you left like telltale things like your fingerprint all over the box.
Or you have a case on your Raspberry Pi that says "it lost."
Or I very carefully wiped off all the fingerprints. Yeah, did you leave any DNA? Did you sneeze on it? Right. Okay, so there's like really good OPSEC, like James Bond level OPSEC. You know, it's really hard to do.
Yeah.
You gotta want to do it really bad.
Unless you're on TV.
All right, proxy ham alternatives. So this is a lot cheaper method than doing that. It's a lot less complex, and you never have to go near the Starbucks. Alpha, this particular model card, it's an 802.11 card. It is advertised as a 2-watt card, but unless you change the regional setting in it to Bolivia, it is a 1-watt card. So my recommendation is if you get that card moved to Bolivia, change the code to BO, lets you use 33 decibel compared to milliwatt, which is 2 watts. Using a Yagi Cantenna, one of the best ones I've ever seen, comes from a company called Simple Wi-Fi. They're one of the vendors at DEF CON as well. But they sell those down there. They'll hook right up to those Alpha cards. Alpha card runs over a USB cable to your PC. You've got the drivers. You can go through and get a pretty decent.
And those are really cheap. That Alpha's maybe $30.
Yeah, I bought the upgraded one, which had an extra clip, so it'll like hang off the back of your LCD, and I think 1 or 2 replacement antennas versus the stock antenna. It was $40 off of Amazon.
The antenna comes with the can't stand up with it, so it'll tip itself over if you use the large antenna.
Yeah, I have mine clipped to the back of an LCD, and it's standing straight up, and it doesn't move. It comes with a suction cup on there too if you want to tack it to the wall or something. These Cantennas I think are about $50 to $60, somewhere around that range. So we're talking sub $100, and you don't have to use the proxy ham.
So, and there is a replacement. Another group came out with Proxy Gambit, which is a published all the specs and everything. It does the exact same thing.
Yeah.
So
on this, it's since you're operating at 2.4 gigahertz, it's really limited by your line of sight here. So if you have not a whole bunch of obstructions in the way, you could feasibly communicate several miles with this guy right here. Now, if there's a big ass hill and buildings and stuff in between you and Starbucks,
Or a tractor trailer drives in front of you.
Or a tractor trailer drives in front of it, parks there or something like that. Yeah.
My uncle lives in the mountains, and he was trying to pick up Wi-Fi signals from down in the valley, and we would go into the kitchen and get like metal strainers and stuff. So,
cheap parabolic.
Yeah. So that's the other one. This parabolic grid right here. That's another antenna style that's a directional antenna, and at higher frequencies, they're not that big. They may be something like about this. You may get 30 decibels of gain on it.
Yeah, the 30 dBi one's that wide and that tall.
Yeah,
and it's a wire mesh.
Yep.
So it's very light. It doesn't have a lot of wind loading.
People have built those with like chicken wire, fence, screen and stuff like that. There's all kinds of plans for the dimensions that you need to be able to build those. Or you can just go and purchase them. The same company, Simple Wi-Fi, sells those as well.
Or an old direct TV antenna somebody threw out alongside the road. However, you won't get 30 dB gain. In practice, you get about 12.
Which is still amazing. That's still really good.
Yeah, and then about 18 at 5 gigahertz. Yeah. Not that I've measured it or anything.
Yeah. All right, I've got a couple ideas I wanted to share with you guys. 2 of these you guys have already seen before. I've presented on them before, but I just want to kind of mention them again. We'll get through it real quick. So this was something I built about 1995. I built a cordless beige box. So if you're familiar with the beige box, Simply, you take a telephone, an old style telephone, can't buy it anymore. You cut the end of the connector off of it, you strip the wire back, and you put alligator clips on it. Then when you go out to a POTS interface box here, you can just clip right onto here, and you're like adding another phone to the extension. Well, I thought, well, it'd be kind of fun to be able to do that remotely. So I went to Kmart and bought a cordless phone, took the base, I cut the connector off of the AC adapter, the wall wart. I stripped that and I soldered in about 5 or 6 of those 9-volt battery snaps that I got at Radio Shack on top of that. Took those batteries, ran some electrical tape around those, made those into a big pack, put the snaps on there, and now I had power for my base station. Well, for the handset, what I did was I popped the plate off of the back for the battery cover, pulled the battery out, drilled a hole in the bottom of the battery cover. I took one of those DC adapters that plugs into your cigarette lighter that has a switch on it that lets you adjust the polarity and the voltage and things like that on there. I cut the connector off of that guy, ran it through the hole in the base plate, split that, stripped the wires, soldered those to the battery connection. So now I was able to plug that cigarette lighter adapter into the cigarette plug, and it would power that handset. So then you could then take this base unit, hook it up to the POT system, drive away, and you now have remote access via cordless beige box. And stuff like that. So that was something I did. I was about 13, 14 when I did that. The denial of service dog. So there's my Wi-Fi pineapple on the back of one of my shepherds here in the hallway. So I bought the Wi-Fi pineapple about the end of 2013. I took this picture and I thought, oh, that's kind of funny. Do like, the dog walking around doing de-off stuff. And then somebody did like an almost identical presentation at DEF CON here. This is funny as can be. If you want a good laugh, you got an hour to kill. Look this guy up. Gene Bransfield did a DEF CON 22 talk, Weaponizing Your Pets, the War Kitty, and the Denial of Service Dogs. So he ended up kind of doing the exact same thing. So one of the ideas I had, there's a company called US Palm, and they got a division called Synology War Lab, Synology being the study of dogs. And they produce a very heavy-duty, 2-inch webbed, Cobra buckle, D-ring dog collar here. And so I've got a set of these for my dogs and take them out for a walk, and then you've got lights for the dog for walking them at night here. Well, these are Velcro that's on here, very strong. It's got Velcro inside and out. It would be very easy to attach a device to this that's not going to fall off, that's not going to slip. If you watch this guy's talk, one of the big problems he had, the first implementation he did, was he bought a dog coat, a small-sized dog coat, and put it on a really fat cat. Well, the cat was like going through the fence on its first mission and peeled the coat back. Then on the second mission, the cat goes out and like loses the coat, which had a cell phone inside of it, and he's never found it. So this was just kind of an idea for another implementation that I had. The same company, US Palm, does a vest that has PALS webbing. If you're familiar with like Molly pouches and things like that, and PALS webbing is what you feed the straps through on a Molly pouch to get it to attach to the vest. Would also work very well with something like that. And here, looking back to Acoustic Kitty, dogs are easy to train. The other kind of vector you can use here, putting something in a backpack, maybe a little bit less conspicuous than some big pack attached to a collar or to a vest or something like that.
So the comment on this is, it's not a tuba.
That's right. That's right. All right, 2 other projects that I've done. I'm just going to spend a minute talking about these, or that I haven't completed. I was working on them, was going through a divorce, and put these aside. But first one was taking an Altoids can and building myself a 20-meter transmitter inside of it, using a single transistor as an amplifier in there, a lithium 9-volt battery to put in there. It's going to put a hand warmer inside of there, and then run some 24-gauge wire out the bottom of it. Attach this to a balloon with a parachute, send this up as a Morse code beacon. I found a single IC 8-pin dip package Morse code keyer that had a 200-character memory that I could record a message onto, send this thing up. It's running, say, maybe 20 to 25 milliwatts. We're talking a tiny bit of power, but if it's up at 90,000 feet, there's a lot you can do at 90,000 feet with just a couple of milliwatts. And the whole point of this was I was probably going to put like a URL into the recorded message and have somebody go through there and be able to submit reception reports, where they heard this balloon, where they're located, what's like that. Interesting things happen at 90,000 feet to 100,000 feet. Your temperatures drop down to about -50 degrees. You got to use special components like a lithium battery that are still actually going to function at those cold temperatures. The other one here, and this one's really cool, and I still want to get this guy completed here, was building a remote monitoring station using a Raspberry Pi and an SDR dongle. And so I've got all the components to do this. I actually just need to finish the code on this. I've got a Pelican case. If you're not familiar with the Pelican cases, they're like this. They're pretty much indestructible, watertight. They've got seals inside of here and everything. But what I've got is put a battery in here to be able to power the Raspberry Pi. Runs over 5 volts over USB. With the Raspberry Pi, using a Model B, you have 2 USB ports. One port, if you put an 802.11 adapter on there, you can then search for Open Wi-Fi, be able to connect over that. And with the other USB port, if you put the SDR on there, you can install like GNU Radio or compile GNU Radio on the Raspberry Pi and run that. Well, you have this device make like say either a VPN tunnel or a reverse SSH connection back to like a C2 server for over wireless. And then once you have that connection established, you can then SSH into your Raspberry Pi and then use GNU Radio to actually control the receiver there. So if you had a large enough battery and a compact package, and I probably wouldn't use blue or orange or something, but like I have another one, a black box with this. I've got a bulkhead adapter that you can drill through the side of this, run an external antenna to for your SDR off of here. And you could literally just go and drop this, throw it in the bushes, and let it run for several days. They're collecting RF data remotely using their Wi-Fi to exfiltrate the RF. So I still want to finish that project, but you know, there's a lot of use cases for something like that you could really go through and you had a particular target who was using VHF, UHF. Well, we know that that's going to be very limited communication ranges. What if you're 100 miles away or 1,000 miles away from that particular target? Well, if you can go through and exfiltrate RF over the internet, it doesn't really matter where you're actually sitting. So I want to go through and do a full proof of concept with that. I've got all the hardware for doing that. I've got all the ideas. I just need to sit down and actually finish putting that
down. So if you were to do a pen test on an organization where the security guards use UHF, you could map out all their, when they go to lunch, when they go on patrol, what their call signs are, all that stuff.
Well, and usually with physical security units like that, they're going to be checking in on some type of a regular basis. If they're going to be establishing routines like, hey, I'm going to go check this building at this particular time, that's a lot of valuable information if someone's looking to go and do harm on something.
Is the Raspberry Pi strong, powerful enough to be an SDR for most use cases? Like, could you replace
power the device? Is that what you mean?
Yeah. So say like, could an SDR and the Raspberry Pi replace the $14,000 ham transceiver?
No. They're different animals. Now there are transceivers that are full function transceivers that are SDRs. It's not a Raspberry Pi and a $20 Realtek dongle. But there's a company called Flex Radio that makes those systems. They're fairly expensive, and everything you do is through an application.
So say like, if I wanted to replace some set of hardware, how much would like $100 SDR and a Raspberry Pi get? Like, what could that actually replace?
A fairly decent receiver or scanner would really be what something that may cost you several $100s. You could easily replace with a Raspberry Pi and a $20 receiver. Is that where you were headed?
Yeah.
All right. So when I finish that, I'll probably do another talk on that. But one of the things I wanted to do was go through and do a write-up, like how they did all the specs, like in the TAO catalog. Do something kind of funny as this being like a NSA TAO device. All right, some inexpensive gear. So I've done a couple of RF talks, and a lot of times afterwards, people ask, how do I get started in RF for cheap? These Baofeng radios. So I've got one here, he's got one there, I got another one in a box here to give away. They are great. Well, they're good.
Good for the price.
They're wonderful for the price. So supposedly these are subsidized by the Chinese government, and that's why they are so cheap, trying to undercut the Japanese radio. So if you were to take this radio here, build a better user interface into it, and change the name on it, it'd be about $150 to $300 if it was a Japanese radio. And these are $30. The one I bought here to give away today cost me $26.50, and with free Amazon Prime shipping, it was $26.50. There are multiple models available here. The base unit is this UV5R, and then pretty much everything kind of daisy chains off of this, some derivative of that. So like this is like the plus model of that particular radio right there. The firmware is a little bit different, but other than that, they're pretty much about the same. So I mentioned antennas are everything. This one comes with a cheap piece of crap antenna. The best thing you will do when you purchase this radio is throw that antenna away and purchase a third-party antenna. He's got one. I got one right here. Be very careful when you go to purchase a replacement antenna for these. They use a reverse polarity system that are common in Chinese radios. So make sure when you go to purchase that antenna, you are purchasing a reverse polarity antenna. In manufacturers such as Comet, look for the suffix J on the antenna, and that means it's a reverse polarity SMA antenna.
There's plenty of guys on the internet that will tell you all about which one to do.
Oh yeah, there's a lot of information about that. Extremely easy to obtain here. Go on Amazon. You can buy, they sell like 5 packs of these things for like, I don't know, $110 if you want something like that. You can save a couple of bucks that way if you got a bunch of buddies who want to buy some of these. They're extremely difficult to program. Somebody produced, so the manual that comes with it is trash. Somebody replaced or produced what should be the replacement manual for these. To program, say, a 2-meter ham radio repeater in here, it's about 60 keystrokes. 60 individual button pushes versus this guy right here is about, I don't know, 5, 10 to do something like this. Do yourself a favor. Do not learn how to program this radio from the keypad. Purchase the $6 USB programming cable. Download yourself a copy of Chirp software, which will go through. You can read the contents of the memory here. You can save that as basically a template, and then you can go through and modify that template and upload it back to the radio, put whatever you want in there. These things come wide open. They're not just limited to ham bands. They will receive and transmit all over the place. But don't do it. The other thing, these SDR dongles. So this is the new version of, that's what is inside of here, is this blue one here. They've done an improvement. It's called the Mini 2. Done some improvements on it. I forget what the big differences are. Amazing value. You can find them about $20 a piece. They're usually going to come in these bags right here where you have your dongle in here. It comes with a crappy antenna and then a remote control in here too. I've never used the remote control or the crappy antenna. Replace the antenna. You're looking for an MCX connector on that is the name of the connector. It's a very, very small connector, micro connector on there. And what I actually do is I purchase these 6-inch pigtails off here. You have an MCX male on one end that actually plugs into the dongle. And then on the other side, you can have SMA, SO239, BNC. These are all common connector types that you're going to be using them with RF systems. And again, use a real antenna when you're going through and actually using these. You'll get much better performance than the crappy one that comes with it. Unless that one is actually probably good if you're trying to listen to some stuff up at around 800-900 megahertz. It may actually be a halfway decent antenna for that range, but for general purposes, buy yourself a real antenna. Some additional references here that you can go through and look at. ARRL, the American Radio Relay League, or now it's called the National Association for Amateur Radio. All kinds of great information about radio, but typically pertains to ham radio. The ARRL license manuals, I showed you the one for the tech here. I got a link in here for that tech manual on Amazon, about $25. If you want to get your license, that's the book to get. Join a ham radio club. You will find a lot of guys that know a lot about radio by joining a ham radio club. The Radio Reference Wiki, if you want to go through and find commonly used frequencies for various systems, that is one of the best places to go through here, and it's just tables and tables of different frequencies. The old Monitoring Times magazines, these things were awesome. So this was that man Bob Grove that I told you about that kind of got blamed for the news helicopter incidents. They sell like archive CDs with the back copies of those. Those are great references to have. The Michael Ossman SDR course. So Michael Ossman created Great Scott Gadgets, who created the Hack RF1. He has an amazing SDR course that steps you through, like step by step. Here's how you do everything in Canoe Radio Companion and dealing with everything with SDR. And he knows 1,000 times more than I ever will about that stuff. Purchasing radio gear locally. Ham radio outlets out on Buford Highway, about 1.5 miles, 2 miles north of 285. You go in there, they got all kinds of stuff in there. You can go in there and ask a lot of questions. Gigaparts, company out in Alabama. They have a very good stock on hand of things. I've never tried to go and order something from them that they didn't actually have on hand. And with being in Alabama, they ship it one day, you get it the next day. They'll accept PayPal and don't charge you sales tax. Amateur electronics supply, there aren't any of those local, but another really big ham radio company. There are others that exist. eBay is a real good source for equipment. I purchased this little guy off of eBay. I purchased this radio off of eBay. I think that was it. But I have some of the other radios that I have at home. A bunch of them I've actually purchased from eBay. So you can go on there and get all kinds of good deals. That is everything that I have.
And also, ACK Radio, if you don't know it,
ACK Radio
is a good source locally for a lot of stuff. They'll have it in stock, so if you need it right now.
Yep. Where are they?
They're over off Deering Road and Northside Drive.
So I know that was a long presentation, and that was only about half of what I actually wanted to cover today. I appreciate it. I did bring some extras, some hardware that I wanted to give away to some folks. I had some folks